Hello, hello. We're going to continue working on the mini cast, cast to mini cast, and things. I was doing some off stream work and I feel like we're getting close. To have the things working. Hello, Nigel. Back to the original camera angle. I mean, I can move it back if you want. If you liked that one more. It's not exactly the original one. I moved it a little bit to the side. Alright, anyway, over here we're trying to compile the hello world from cast to minicast and from minicast to JavaScript. Looked very cinematic. Alright, hold on. There we go. Absolute cinema, right? Okay, here's the issue, right? We have this issue where I have the iterable type T, but we got iterable type T, and these are different types because there are different T's in the world. So how about we do this on the playground though? I was trying to do this earlier, but it did not work. And why is that? Like, why is it over here, for example, correct, right? Is the question. And I think I know why. Right? I think what we want I think what I want is I want to have like a generic type, you know? Like this is generic type T, which has, you know, field of type T. And then we have a generic function, right? Which is a function which takes field of type T and returns generic type of type T. Like this. Let's say x is equal to generic function hello world, right? I think this over here is actually going to work Well, okay. First of all, there is a to-do over here when I'm printing a type. Let's fix that. This over here is non-exhaustive, apparently. Because we don't have a reference. Okay, right. Yeah. Let's do a reference here. Send a ref, like this, right? Okay, here we go. Let's try again. All right. So we have a problem that we expected to has generic type string, but we got generic type t, right? So like this is basically the same error, right? This is basically the same error. Because we can look at this, right? So here's my main, and I am creating the x. I don't know why there are two underscores here, but that's okay. Whatever. So we have x, which is of type generic type string, well, right? Because this is what it is. Actually, over here, this is the type of x as inferred. But the generic function, right? It obviously returns the generic type t, and this is different. So the question is, how do we make this type check? What do I even like try to transpile this into? Right? Let's try this code in the mini test over here. Mini generic. Let's do this. So we have a generic type like this. We have a generic function like this. So over here we call generic function with string like this, right? But this is not correct minicast. So what do we want to compile this into? Is the question. We want to say that x is equal to generic function string hello world. String type info. String type info is type info, which is empty. Type info is like a struct, which is empty, right? And what else? The generic function itself. is the function that takes a string, which takes a type, right, and returns the function so this is supposed to return a function that takes t. So right, this right here is t, right? This returns the function that takes t, which becomes any, and returns the generic type t, which we cannot specify, right? So this is going to return a new function which takes a field of type any, right? And returns generic type t, which is now going to be an object where field is equal to field. Right, and this type over here is supposed to be generic type string, right? So this obviously doesn't type check. Let's call this generic type t, and let's call this generic type string, right? Because we don't have generic types. So instead, we actually create the monomorphized types here. So generic type string would be a struct where field is string, right? And then generic type t is supposed to be the type where field is any, right? But even although this is so, this type is not coercible to this type, right? And so this does not work. This must be in parentheses. Right? So we it's basically the same error. We expect a generic type string, but got generic type t. And we need to figure out what to do here. And I just realized that I should have went to the bathroom before starting the stream, but oh well. We're going to take a bathroom break here immediately. All right, what we're doing here. Okay, we have this problem. We're in presence of generics. We need to figure out how to compile this, right? I'm pretty sure we don't want the generic types in the language here. So what do we want? Like, I can have anything that contains a generic argument in the type, like to be any, right? So like this would be just any, returning any, right? Because that's what it is. This is a generic type, right? How do we specify it? That's impossible, right? But then what is this field? Well, I mean, what is the type that I am initializing here? I mean, this is supposed to be this generic type T, right? We just want this type basically to be actually conversible to this type. Might as well just make the many guys dynamically typed. No, 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 no. No, 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 no. Let's open up the existentialization thing again. No, we only do it for generics and only in the mode where we don't monomorphize. If we monomorphize, then we can have all the types, of course, right? But I'm interested in doing this without monomorphization. So do they have an example of this? Right? What is the type that is generic? Over here, you have area fully existentialized. So here's the function area, which has a vector T of shapes, right? And we return the total area, right? As you can see, this vector T is basically a void star. It is dynamically typed, right? As you have said, but you only do this for the generics, and like you don't have a type vector void star, right? You actually have void star for any type that contains the generic, right? Is there like an example where you return something generic? No, but like, I mean, it should be the same. It's just like, how do you construct the generic type is the question, right? So like, because I feel like we still need the generic type T over here, because this is what we return here, because if we don't specify this type, then we cannot initialize the struct, right? Also, like, what is the representation of this generic type T in memory is the question, right? Like, because when we want to do it without boxing, so what is specifically the definition of the any type actually, right? That is a question. Any type is a void star, but like, we want the representation here to be the same. We don't want, when we coerce from this type to do any transformation, their in-memory representation should still be the same when we are talking about like C. And I mean native compilation in the future, right? So it should be something else here, right? Because this should not be a pointer. This should actually occupy the same space in this struct as the final thing, right? Which means that we don't actually have a generic type T. Instead, we have the type. We have this type info, right? And this type info is what's holding the information about the type, right? Like what is the size of the type? How much should we allocate of the memory, right? How much memory should we allocate for this, right? Like there is the alignment here, right? Alignment, size. And then we also want to kind of be able to initialize this field by field, right? So like we have T and then we have generic type T, which technically means that we should still transpile the function, right? Which has the generic type, right? Like this over here. This is a generic type, which is a thing which returns a function, right? So we should actually still have this function, which takes T as type info, and this returns a new type. So it also returns a new type info, right? So the question, what is this new type info? Let's size and alignment is like when we do the lower level stuff, right? But what we want is the information about the fields here, it seems, right? So in order to initialize this, well, we need to say that result is uninitialized, right? And then we say result.field is equal to field, basically. And then we return result. That's what we transpile this into already, right? So the question is, how do we do this? Result.field is equal to field, right? Because this basically is a runtime information, kind of. So in this case, we want to set field, right? So does this mean that the type info should basically allow us to, yeah, type info should like basically have a set field, right? Which is a function which is like self of type any, a reference to any, and then field which is a string, and then the value which is like any, I guess. And this is how we set the field, right? So for example, when I have the generic type, I should have, I mean, this should be like, what? We can have like just like field, which is a reference to the field, right? Like this maybe. So this type info would be an object where field is so self is any and field is string, right? And this should basically return if field is equal to field. Then we return. reference to. Well, yes, and this is where we actually have the generic type T over here, right? Where field is any. No, that's not correct. That is not correct. Like, this should be like low level then in this case. Right? Like, we need to calculate the offset of this field at runtime. Like, if we were doing the C, if we have two fields, what's the offset of the second field? It depends on the size of the first field, right? So we need to calculate that at runtime. I just realized I was muted all this time, right? Whoops. I was just talking to myself. Or did I just mute myself? No, I just muted myself. No? I don't know. I don't remember what happened 5 seconds ago. That's what my memory is like. I'm not sure here what should be done. Right? Like not sure what should be done here. So result over here is going to be yeah, like we need to be able to like construct the new value of this type, right? So this over here says uninitialized, right? But we should actually like I don't know, create new type, create new, I don't know, let's just call it new T, right? That's what we want, new T, right? Like how do we create a new instance of a type even? New is a function which takes type info and returns what? It returns any, right? That's the definition that's supposed to be here. So this is supposed to be uninitialized, but we can, like, this is not exactly correct. Because I need, like, I cannot compile this to C, really, right? We need to know the size. Like, it's almost like this should be the built-in. It's almost like the type info should be built in into minicast. And this new also should be. Right? Because, like, in order to transpile this to C efficiently, we need to know, we need to actually use the size argument here, right? Right? Yeah. I mean, we can have, like, uninitialized to have arguments, right? Like t dot size, right? Basically. But technically, this size could be, like, different. Like, this is specific to certain backends. And I want to not do that. Right? Like, there is no size in JavaScript, for example. Okay, I'm kind of stuck a little bit. Need to figure out what needs to be done. I mean, we can always just go for monomorphization, I suppose, but I don't like that. It feels like the type information should basically know how to construct this thing, you know? New is a function that returns, like, any, basically. There we go. That's what we need to do, I think. Yeah. So we don't say, like, new anything. Yes, we over here say t.new. That makes sense. Because then, like, and over here, it's not t.new, right? It's basically generic type t.new, like this, because that's what we are returning. So generic type is a function that returns the type info so that we know how to initialize this, right? And over here, we say new, right? Which is a function which is going to return uninitialized, but not of type any, right? Because uninitialized basically can never be of type any. I guess this should be the error, right? So we should instead say that this is uninitialized of type generic. No, because this is generic type of type info, right? So, like, this should, like, construct a struct. Okay, maybe this should be, like, built in where we have a function, you know, like new struct. Right? Yeah, and this is not like part of this then. Well, I mean, for some types, this could be like the type itself, right? If it's a statically known type, then we can just say uninitialized. But otherwise, we should have a new struct where we have like the fields and everything. So this over here would just be new struct. Of this thing. New struct of the result. Well, I mean, new struct should just like, yeah. Size alignment. Right, like new struct. Type info. Yeah, I feel like this maybe should be the built-in thing then, right? Because like it's the we know how to create a new struct for the backend. But we need some information, right? Well, let's see here. So like for the JavaScript, I guess we would just say this thing. That's how we create the new struct, right? And then if we say, okay, JS new struct C, this should basically return like malloc or whatever, right? I mean, it's not like malloc, but yeah. And by the way, like in C, wait a second. Wait a sec. I just realized, like we don't return types in C, right? Because this is we don't know the size of it, which means that when we transpile to C, we need to have the return value as the another argument, which is getting allocated by the caller actually, right? It is allocated by the caller. So we don't even do malloc here, right? In C, I actually don't do anything because it's already allocated by the caller. Yeah, because basically we cannot have any without a reference, right? Which means that we never return any's, right? And this doesn't do anything. And this doesn't do anything. And this just has a result, or I guess return, is a reference to any, basically. There we go. So I would just say that a return is equal to this. which means that this is like unnecessary anyway. Like this could be done when we are allocating it. So generic type is also a thing which does not return any, right? This also has the return, which is a reference to any. It doesn't return anything, right? So this is supposed to be... Well, I mean, is there any initialization that even needs to happen? If we do it like that? Yeah, but like over here, I'm trying to create the local, right? So how do I make the local here of this type? Back to this question. This is weird, right? Like the allocation needs to happen over here technically, and we can allocate on the stack in C, but and then over here, this would be like, you know, generic type t dot field of the result called field, right? And this is supposed to be equal to the field. There we go. And we cannot have the argument of type any either, right? Wait, can I have the argument of type any? I cannot, right? Because this would also, like, we actually need to have it behind a reference. Always. Should we? If I'm trying to do the C stuff. This would be a reference to any. So the field over here, and we cannot just dereference it because we don't know the size of it. But we know that the type of any is T, right? Which means that we need to basically say T dot copy copy from the field into over here, right? So the type info should have the copy, right? Which is from and into, right? That's what we want. So new is not something that is happening actually. So I want to copy the field into over here. This over here is not very efficient, right? Me getting the field, but the order of the fields is still the same, right? We basically, yes, actually, the order of the fields is going to be fixed, right? Even for the generic type, because it is still like the same type as this one, right? So we should basically just have a fields, which is the list of something. It's the list of what though? How do we like list of the field? I guess is what field info maybe. And then we have over here field info is struct, right? So this field, get this field, is a function which takes the reference to the struct, to the object, and returns reference to the actual field, right? So we can get the field numbered something because we actually have the numbers, the indexes, and the indices are supposed to be like the same for this type and this type, right? So we just say fields 0 get result like this. Or here we say that generic type T is generic type T. We don't have the indexing operator right now, but I think that we will. For the lists, I mean, I can also just say like at. No, I cannot because because it's like a generic function, so it's like must be special here actually. We don't want generics. So I actually want the syntax here. Let's use the syntax for now. So we have generic type T fields get result. And then we copy the field into this field of the result. And then we can return result. Yeah, but the result, we don't know the size of the result either, right? Like this is not supposed to be working because this is a generic type technically, right? Well, I mean, we can say like that when we return any, right? Because that's what we return here. I mean, do we return any here? I think we do, right? I think this returns any. So we can just say that when the function returns any, it actually like, but only when we transpile to C, it gets the result as the final argument instead, reference to it, right? Wait, can we do this? Yeah, because like now the caller needs to like know the size of the thing. That's the issue here. Which basically means that yeah, and this like solves this question, right? Who allocates this here technically? This generic function. Because it is this caller that is going to allocate it, right? We are giving it the information of the type, but we are also, instead of saying let x be this is going to be basically uninitialized. Right. Hold on. We just say that this is uninitialized, and then I pass the reference to x here, which is the like the return generic function. So we don't actually return anything. We say any, right? Field and the result. Return unit. So we don't do. I mean, we do this, right? But then I just say, yeah, we don't say new, right? We just have the result here, and we get the field of it like this, because this one is already allocated by the caller. Hello, Ben Chilling. Welcome. We're trying to figure out how to compile generics without monomorphization here. and without exposing too much details about the compilation target. About the final compilation target. Copy any this is a function that returns nothing, right? Yeah. Fields, list of field infos. All right. Well, this is going to hurt the performance of like JavaScript even further though, because we go through all of these interactions. I'm gonna use dynamic dispatch. Yeah, it's like interesting here, right? Because I need to figure out how to construct the types. We want this to work like fast, right? Dynamic dispatch can be done in multiple different ways. First, like I guess the easiest approach is to just box every value, but that is not very efficient, right? Obviously, well, I mean, monomorphization would be the most efficient anyway, right? But even if we don't do monomorphization, there are multiple approaches. You can box every value and then it would be okay. And things would work. But it's not very efficient. So we want to be still somewhat efficient in terms of like memory management, right? So if we have, so over here, right? I'm trying to compile this code. This is the example code in Kast, right? So we have a generic type which has a field of type T, right? And then we want to say X is generic function. Let's do an integer here instead, 1, 2, 3, right? Like this. So we don't want this integer to be boxed inside of this field, right? We don't want this to leave behind an indirection, right? Maybe we should open up this C so that it's even like more obvious what we're trying to do here, right? So we want to have generic type. Let's just copy this here. Like this, right? So this is the code that we're trying to compile. Wait. You can just do this, right? There we go. So this is the code that we're trying to compile. How do we do this? Right? So we want to have a struct. The T is what? Is a generic. It's a generic. This is a generic type. Have you seen? Do you know any language with generics? We just have this syntax here. Right? Let's do over here. This is like Kast, right? And then this over here is going to be like Rust, for example, right? This would be struct generic type T, where you have, you know, field of type T, right? That's how you do it in Rust. And then you have function, generic function T, where you have field of type T, and this should return generic type T, where you just return generic type field, right? And then you say let's do main, sure. Let's do main. You say let x, which is x generic type I32 is equal to generic function I32 1, 2, 3, right? Let's make it very verbose here like this. Even although like the things can be inferred. In the implementation, do you box it or just put field in a register or standalone in memory? Yeah, that's what we are trying to figure out. But we don't want to box. Boxing is the obvious technique, but it's adding the overhead, which is, I guess, okay. We're doing the overhead anyway, but if we can minimize the overhead, that would be better, right? So that's what we are trying to do. This I'm like trying to do existentialization. It's called existentialization, where you don't box the things. So here's what we're going to do here to compile this into C, right? So we will have the function generic function, and how do we make a generic function without like making different copies of this function, right? It basically means that our T is a is like the type, you know. So we'll have the type called type, and we pass the type as the runtime argument. This is the information, the runtime information about how the type is supposed to be represented, like in memory and stuff, you know. So instead of like making this, so in the classic approach, you box the value and you have this type information alongside each value, which is not very efficient. Right? So you have type T, and then you have the field. So the field here is of what type? So this is supposed to be of type T, but it obviously doesn't work because T is not a type. T is an argument here, right, of this function. So instead, you say that it's a void star. A void star means that it's a pointer, but the pointer does not necessarily mean that it lives on the heap. It can still live on the stack, right? And then over here, we return something. So what do we return, right? We return generic type T, but we don't know the layout of the generic type T, which means that, so on one hand, we want to return the void star, right? But we don't want to allocate the memory inside of this function. We want it to be allocated on the stack, which means that the return value is instead being the last argument, right? So void star result, and it is the caller who is going to allocate the result here. Okay. That's what we are going to try to do here. So what's the type? We just say type struct type, right? And over here we have like some information there. Right. So over here we are trying to create this object. So technically we already have this object. This is allocated by the caller, supposedly, right? So what we're going to do is we just need to like move the field from this place to this place. So the type information, I think that the type information should contain the like how do you move the thing. Well, technically, because this is just C, right? We can just say, is there a size T in C, right? Size T is size, right? So if we have the size of the type, then that's all that we need, right? Because then what we do is we just do mem copy, right? Because we need to assign the field here, right? So we just do the mem copy of the what is this? Target, source, and size, right? So what's the target? So result field, and T dot size, right? Okay, so the question is now, what is the result field? Right? Result field. We need to basically get the field of the result. Right? Which is like a struct. So we need to know the information about the types, which means that the type information is going to have the you know, fields, which is the list of types. Is that what you do? Type requires, okay, would you like struct type? Is this not the correct syntax in C? You don't do like this to specifically say that it's an array, not just any pointer? Okay, so we can have like a star like this, right? So we have the fields. So result field would be the yeah, result field would be basically, so we need to first like figure out what is the type information of the generic type, right? So we need to basically convert the type definition into a function that returns the type information about the generic type based on the type of the argument, right? So like this is literally going to be converted into a function, right? So we have the basically the type, generic type, which takes type T as argument. Vim jump scare. Right, so we do this, and we say like type result. We say that result size is equal to T size, and we say the result fields is malloc malloc size of type times 1, because there's only one field here, right? And this is going to be like, you know, type star. Is that not correct? Call to undeclared, we need to include stdlib.h. Okay. What is this? Oh, it should be like, I should actually say struct type star. Wait, what? Okay. Sure. Should I say over here size of struct type instead of size of type? No. Size T is kind of vague. You think it's 8 bytes, but since you use a pointer to a struct, it's going to be 16 bytes. What? Since you use a pointer to a struct, it's going to be 16 bytes aligned. What? No, I mean, like, no, I'm pretty sure that this is like the size. This is going to be like 8 bytes on 64-bit machines, and this is going to be 16 bytes in total. 8 bytes is huge to store as size of byte taken by a type. Yeah, I guess. But should this be like, this is like a super micro optimization, and like even if you don't use the size T here, this over here is a pointer which must be like aligned anyway to 8 bytes. So even if I make this smaller, this would still be aligned. I guess I maybe like, does it work so in C like that? Like if this is the you know, let's call this type size, right? So if I say that type, can you have type aliases in C? That's just type def, right? Type def size T, type size, right? Like but if this is not a size T but like a U8, because this is like after the field, it does not have to like introduce the padding bytes into this struct of the type, and this would be like actually smaller than. But I mean, this the type itself still needs to be aligned to 16 bytes, which means that there is going to be padding at the end of the bytes in order to create the thing. You know what I mean? And in 32-bit, this would be the 32-bit pointer, and the size t would also be 32-bit, which is going to be 8 bytes total instead of 16. But like, what I'm saying is that even if I store the size of the type is something which is like just 1 byte, then this is still going to have the padding bytes in the end. Because otherwise it is incorrect to have the array of types, because then the pointer would be misaligned. You know? So it doesn't really matter, and we can just use the size t here. Which also is like I don't know, like, it's 255. If I change this to like a single byte, it might not be enough to store the size of a type. If we for some reason have types which are bigger than 255, right? Especially with fixed sized arrays, this could happen, right? Fixed sized arrays can be like whatever you define them to be, right? Though you would probably normally not use the whole memory. But yeah. So over here we return result. Okay. So like, this is a function, by the way, which is supposed to technically do memoization. So like, same with like generics, like in your language, when you instantiate the generic multiple times, it's supposed to give you the same result. So over here, there should also be memoization, basically. So, but we do this at runtime instead of at compile time, right? And we do that because we want to save on compile times. So yes. So this, yeah, whatever. You know what I mean, right? So we have the result field, which is going to be fields. How about, oh, okay, hold on. How about we have this as like field, right? So what is the field? Type abstract field. So field would just have the offset, I guess. Which is the size t also, right? So then we just say like get field of result, right? Well, first we need to like construct the you know, type. So like, what is the generic type t? Generic type of t, right? This is going to be the generic type t, like this. So now we have the type information, and now we can say generic type of t fields 0, right? Because we know that there is only one field in this. Call to declared function get field. Oh yeah, no, that's correct. What is this though? Subscript of a pointer to incomplete type struct field. Oh, I need to like say struct field here too. There we go. No, this is not the field. This is type, and this over here is field. Ideally, offset is 32 bits max, since you can use displacement encoding and move instead of add plus move every time. I'm not sure if that's true. Displacement encoding. What's displacement encoding? Mod RM. Displacement in x64 encoding is a 1, 2, or 4 bytes and offset based add to the base index registers. Determine mod RM bytes mod field. Okay. So there's like dedicated operators to like add the offsets. Right. I guess. Yeah. I don't know. I have written a little bit of assembly, but not too much. So the offset is what, like, we can call this like offset T, you know, and we say that type def is like, why is there not a dedicated one in like in C then? The type of offsets, that would be like making sense, right? Oh, I mean actually there is this offset of, right, in std-def offset of, and this gives you what? Offset of like type and field size, for example, right? std-def. Let's see. Right, this is built-in offset of, which is what exactly? Like, what's the type of this is what I was wondering. Yeah, type is unsigned long, right? Which is of size 8, actually. I mean, if my LSB here is correct. Which, I mean, is probably, like, because it calculates the offset as, like, basically... I don't know. I mean, this is built-in. You know, I don't know. Yeah. Well, I mean, usually you calculate it by, like, creating the uninitialized value, right? So you say, like, type T, and then you, like, basically say reference to T dot size minus reference to T, right? And this over here as, like, so this is the pointer, you subtract the pointer. Can you subtract void stars? Offset of size, right? You subtract the pointers and you get the offset. Yeah, but I guess you can like store it usually somewhere. Maybe you're right. But yeah. Okay, so we construct the generic type T here, right? We have this. We have the result field, which is get field of the result, and we give it like the field information which knows the offset, right? Which means that now we can do void star get field void star. So we have the object, and we have the field, which is the so the field is given to us in the form of like the field, right? So we say basically object plus field offset, and that's what we do, right? And that's what we return literally, right? That's what we would do it in C with just the offsets. And this needs the reference, right? And now we mem copy the result field from field and the size of the T, right? And that's how we have initialized it. Now in main, what we do is, right, so we want to say this, we want to say this, where X is a generic type I32. So what we can say is we can say that void star X is, and this is where we want to allocate. Hold on, C allocate on stack. Alloc A. Is what you do. Allocate a block that will be freed when the calling function exits, right? So you like allocate on the stack here, and the size over here is going to be the size of generic type I32, right? So we can say that type generic type of I32. Let's call it int32. So this is going to be generic type of int32, of course, right? Then we will have somewhere. So the int32 is like the built-in type, but we will have the information of it over here somewhere, where we have type type int32. I think you can do this, right? Do you have like dot size is size of int, right? There you go. That's what we can do. And we don't care about the fields here because we're never going to access the fields of an integer, supposedly, so we don't even need to initialize them. Right? So we do this. Generic type of int32 is this. So we allocate on the stack generic type of int32 dot size, right? And then we call generic function. We give it the int32 as the argument, which is like the type t, and then the field itself is the 1 to 3, but we need to have a reference to this, right? So we need to have like a void star, a reference to int 1 to 3, right? And the result is going to be just x, and that's what we compile into. What is this? Can you take the address of an R value of type int? Oh wait, you cannot have the addresses of the R values in C. It does not create a temporary, so I need to like actually create this temporary first, right? Const 1 to 3. So, and then we say like int const 1 to 3 is 1 to 3. Right? Well, I mean, technically this can be like a static because it's a constant. Wait, can you have a constant in C? Const 1 to 3 is 1 to 3. And can I const, did I say const int? And I can have a reference to a constant, right? Because this just lives in the data section, and this is okay. You can't really force it to be a real constant. Well, doesn't this live in the data section, which means that like the operating system is going to prevent you from modifying this when it's loading your binary or something? I mean, it depends on the target platform too, I guess, maybe, or something. Right. So does this make sense? What is this? Incompatible pointer types. Assigning to struct field star from struct type. Star. Result field. Yeah, because over here we're supposed to say like field star. Because because we're allocating the fields, not types, right? Yep. Yep. So it's like this is what we are supposed to compile into if we are doing the C, right? So why is this good? Because we still have the data on the stack, right? So we don't box the values. And we don't monomorphize, which means that we have faster compile times. We do lose some of the type safety, but this is like not the code that you write by hand, so it doesn't really matter. Yeah, like the biggest overhead here is basically like this. When I'm accessing a field of the thing, right? When I'm accessing a field of an object, which is like generic like this, we need to, so like get field is basically like this can be inlined, right? But we still need to like figure out the offset of the field, which needs looking at the type definition, then like offsetting, like getting the correct field, getting the offset there, doing some pointer arithmetic. So like this is the overhead. Plus there is a little bit of the overhead on creating the types and looking up the type definitions, because in order to look up the type definition, this is over here, right? We need the memoization. This is like the malloc, which has the overhead, but it doesn't matter because this only happens once for every type. But memoization is like looking up, has this generic type already been initialized or not, instantiated or not. All right, so this has the overhead, but that's okay. Boom, boom, boom. Also, instead of malloc, we could like use the arena for all the fields and things, probably, right? So we don't actually malloc or whatever. So let's move back over here to the minicast. Let's make this fit into the screen here. So in the issue, let's also maybe hold on. Maybe I should so like I'm trying to target not just C but also JavaScript and Golang, but I feel like Golang maybe we will not have it on the screen here. Let's just do the JavaScript real quick. Why don't you make branches in your type constructor with variables? To hold the constant values of the type info. Branch is your type constructor with variables to hold the constant values of type info. What does that even mean? Yeah, so this type constructor, you want to do something? What? Branches, variables to hold the constant values of type info. What is the malloc for? Well, I need to construct the type. It's I mean, okay, sure, sure. We don't need the malloc. I agree with that, right? Yeah, yeah, I agree with that, right? Like when we compile this, we can have the constant, right? We can have the gen. Well, I cannot. I cannot do this. By the way, I did not initialize the fields, right? Over here, this is not complete. We need to say like result fields 0 is the field which a field should have like the type too, you know, type type, right? Struct type, right? So field 0 is type is t, and offset is 0, right? You cannot do this? field is this. Yeah, and this like takes the reference then, right? T size T. Yes, you cannot have a constant because like the fields are different based on like the generic. So because like every generic type is different type, right? This cannot be a constant here. Your color has the constants then. Well, I mean, then the generic function would not need to only know about the T type, but also the structure of generic type, right? So basically, this generic type of T could be passed as another argument because that's like required to call this function, right? But this is not practical, no, because it means that basically when you're calling into generic code, you basically need to know the structure of all of the generic types that are ever being used inside of the function, like including the functions that are used inside this function and like so on, right? So like this is just too many things. No. You need to basically know the definitions of all of the types that are used like while running the function, which is too much. And if I pass all of them as arguments, this is going to like be not efficient because of too many arguments or something anyway, right? Yeah, all of the types needs to be by reference, I suppose. And this should also return the type star because this is going to put this type, in like the type result is type malloc, size of type. So we actually do this here. These mallocs though could be the arena, the global arena object. So yeah, but this is like not the expensive part, right? Because it only happens once. It's this to do here, which is the checking if we have done this before or not. Let's open the JavaScript over here. Size int 32 like this, right? Okay. So here we have the program. Are you gonna put all types in the same arena and have the length prefix a little bit like strings? Do you know how big things are? I don't think we need to know how big things are, but yeah, there is like only the single global arena because we never need to deallocate these things. We only allocate them and we just do the like bump the pointer and that's it. So like we have the arena for types, arena for fields, and yeah. Well, I mean, this arena could be like the it doesn't need to be like statically allocated, I guess, because we never know. But yeah, we could make like, but yeah, how many arenas per program? Well, one arena for types per program, right? But the arena can be like different things. I feel like if we don't want to like specify the maximum amount of types that is going to be required for the program, then we need dynamically allocated arena. Yeah, we defragment, we do segmented arena. I think is that a name for the thing? Is there such a thing as segmented arena? Segmented arena. Yeah, we don't do like a single large block. Chunk arenas. Yeah, basically it's like, you know, like similar to the like dynamic arrays, the way you do them. But you don't reallocate memory when you grow out of the capacity. When you grow out of capacity, you instead allocate a new segment, right? Which is basically like twice the size of the previous segment, and you start like allocating the memory from that basically, and then like your memory does need to move, so like my pointers don't need to be invalidated, right, to the types here. Otherwise we could also like reallocate the memory, but then it needs to be not a pointer but an index, which adds another interaction, I guess, right, a little bit. So yeah, I don't know. I'm not doing the C backend yet, right? This is just me thinking about the future, and I'm trying to I'm making the minicast, right? So I'm trying to see what I need. So let's do the other backend, which is the JavaScript, which alternative of this. And how do we transpile this code to JavaScript? A growing global arena made of chunks can be removed and replaced later with other chunks. So you don't just grow infinitely. Well, we don't grow infinitely because there's not an infinite amount of types in the program, right? So yeah, and like because we never deallocate, like it's a, yeah, I don't know. We don't grow infinitely. Not sure what you mean there. All right, let's do the JavaScript here, right? So we have function main, right? I want it to be like looking as close as possible, and then we like do the common interface in the minicast. Is the idea, right? So we have function main, we have function generic type, which takes t as argument, right? So I want to say that, okay, let's do like the simple stuff first, right? We want to return the object where so we don't care about the sizes technically, and all we care about is the fields, right? And we only have a single field here, and we don't do the offsets, right? Field is an object which has type which is t, and it also, so like instead of the offset we say get in this case, I think. And get is self into self.field, right? That's what we want. So then we return this is the only field, Then we have the generic function, which takes the type T, which takes the field and returns a result. So over here we can actually return, I suppose, right? Yep. Well, and field should have both getter and setter, I suppose. So this would be like self and value into self field is value. I mean, we can also, I mean, technically, if it's a field, we should just have the field name. So instead of the offset, we have name, right? Which is field. Yeah, I suppose this is what we do. Down. Which I can call offset too. Right. Then we will have the function get field, object field, and this just return object field, right? If we can make it like 1-to-1. Right, so then we have the const int 32 is an object. Can I have the types? Can I have the JS docs style types? Argument T. You never use JS? Yeah, I'm just like wondering if we can do something with JS doc here. I mean, I could do the TypeScript instead also, but just so that we like still have the types is the idea. JS doc. Param. You do in curly braces and you do param. Right? Param. And this gives me the type, right? And the returns. Yeah, there you go. So star is the any. And then I can also like specify the types, right? Can I specify the custom types? This identifies the type of a variable or property. Type def. Yeah. I need to do like type def somewhere. Type def, right? Type def field. I want type def. I want to know this so that I don't like actually have to use the TypeScript. Type def. So you do the objects, right? Is just in this thing. Type def field. So can I just say that field is like this? Yeah, there we go. You do the double. So the first curly braces is like because that's where the type lives, and this is the actual definition. So this should have the field offset, right? Which in this case is going to be a string. And then we have the type, which is a type, right? Type is unresolved though, so now we need to like type def type, right? Which is going and have the fields, which is list of fields. No, this is not how you specify the list of fields, right? How do you specify the list? Array of fields, right? There you go. And then you have the size, which is a number, which I mean, so in JavaScript we don't really need this size though. There we go. So int 32, this should be like type type, right? And I don't have the errors anyway. All right, hold on. I need another bathroom break. All right. Can I make the JavaScript language server to like complain about the types? Because like this is obviously not the correct type now, right? Because it's supposed to be the type which has fields and size, right? JavaScript LSB require like type check. JavaScript language server is not a thing. Well, what do I have here though? Well, I mean, yeah, it is TypeScript. And the JS doc, this is basically also TypeScript, right? So yeah, can I make it like strict or something? TS check at the very top. Like this. There we go. We just do TS check. So we say that this is missing the properties now, right? So size is undefined. We don't do the size technically, right? Undefined is not number, yeah. We just say like 0. And then we have the fields, which is no fields. All right. So yeah, and then this implicitly has any, and we need to like specify the type, right? Okay, over here we have the param obj, we have param field, we have returns. Okay. Okay, let's see. This should return the type. The T should be type, right? Get field object. So I mean, in this case, it actually is any because this is the void star, right? The field though is like field, right? And over here, yeah, we don't say field, we say field dot, like, I mean, we call it offset, right? But we should probably, can we like, can I rename actually and call it name now? I can. And it like renamed it in the thing. What I don't like is that it doesn't format the types though. So like TypeScript is directly is better. Can you make it format the type definitions and stuff too? That would be nice. And well, get field is supposed to give me the reference, you know? So we are going to have the reference. Type def reference t. Can I make this generic type? I should be able to, right? So can I have reference t is like get is a function returning t and set is t can find name t. JS doc generic type. Oh, you say like template t type def object box. So this over here is a template t ref. Wait, what? This doesn't work. Okay, no, this works. Okay. What is that? Semicolon expected? Where is the semicolon expected? Oh, because this should be like void, right? No? No! Why is it so difficult here? Have you ever heard about the double-sided arenas where instead of two vectors, you use one stack with two types that grow in opposite directions and you check if tips touch during allocation? And what do you mean instead of two vectors? Do you do a regular arena with two vectors? I thought the regular arena is just one vector. Or do you mean like it's the arena for like two things? Instead of double arena? If you want two types, you might have one vector per type. Yeah, I see. Yeah. Yeah, sure. You can reuse the memory then. But like also you can just do the arena with like as many types as you want with a single vector. You just need to always like make sure that you like go to the proper alignment first and then like allocate in this single vector. And you don't need to do the opposite sides then, right? You will just have a couple gaps, potentially. And yes, I guess you don't need the gaps then if you do the two sides, but that only works for two types. What if you have three types? Oh, you need to do this. Oh, I see. Okay. So I have a reference, which is, yeah, okay. This is ugly. Okay. Well, I mean, it's better than nothing, I suppose. Yeah, we can also do like, instead of this, we can make this thing to be the object. And we can have the property of this type. This is get, right? And then we have property of this type, which is set. Is that right? There you go. This means that it doesn't have to be like in line like this. Hmm. All right, fields, a field, type, field. Does have offset. It has the name of the field. Type is this, and this is missing the size. So size is 0 because we don't care about it actually. Okay, let's see. Now we have the generic function. Parameter t is a type, right? Then we have parameter field. which is any, right? And then we return, what do we return? We return the result, which is also going to be any, I guess, right? Okay, generic function. We want to, basically over here, we're supposed to create the thing, which has the field, right? So we kind of like, so this is the difference. Over here, we can create this object inside of this function. Instead, so we can say, okay, let's also say like over here, type const generic type of t is generic type t, right? Then we say like get field. Well, get field, shouldn't this be like the reference to something? We don't know to what, right? Yo. Hello there. Thank you for the raid. Welcome. Hello. Hi. How's your stream? How's your day? Griffin. All right. Welcome, guys. Ooh. How are you doing? I am here making a programming language, and right now I'm like, I'm looking into how to compile the generic code, basically. And there is in general multiple approaches that are popular. One of them is monomorphization, where you like create a dedicated function for every like set of generic arguments, basically. And another approach is where like you just do the type erasure, and then like you are working with dynamically typed stuff, basically, right? But this type erasure can be actually done in multiple ways. And what I'm looking into is the process that's called existentialization, which is what the Swift compiles into, where you do the type erasure, but you don't like box every value in the like basically you don't box every value, so your generic types are still like laid out properly in memory, like if they were monomorphized. So here on the left we have the simple code, which represents the idea in C, and I'm trying to make my programming language transpile to JavaScript and to C. Right now it's only transpiled to JavaScript, because that's just easier to do. But we want like the native backend in the future. And technically I'm right now working on this middle language, which I call the mini Kast. The main language called Kast. And the mini Kast is like the simpler language which doesn't have generic. So this is where I want to like have this abstraction over the like representation of the generic functions which are not monomorphized, but still would allow me to be efficient and allow me to compile to both JavaScript and C. Type erasure is when you make something static. I don't know the name for it when you make it generic though. Type erasure is when you make something static. Well, I mean, you type arrays in things like TypeScript when you compile to JavaScript, right? Like this is what we have here with the JS doc. These types, they exist, but then they are going to be erased completely at runtime, right? And something similar happens in like Java or whatever. I mean, there are some types, but in the JVM bytecode, I think, right? But yeah. And like similar to this example in C, where we treat the generic data because we don't know the actual type of it as void star, which is also the type erasure, right? We erase the type, we just have the pointer to the data and stuff. Can you show a generic function example which has two different abstract instances? What's an abstract instance? Like, which is the function that is instantiated twice? Or what? Here's the generic function. I can just like... I can just call this function twice, right? So we have this generic function, which is called with hello world, and it then is called with 1, 2, 3, which is an integer, right? Like this. So in this case, we have the generic argument, which is string, and in this case, the generic argument is int32, if we want this to be explicit. And this is going to work. Okay, if I just do Kast playground test. Well, this is not going to work because yeah. Let's use the standard library instead of this. I was like trying to do a specific thing. Let's do dbg print x and dbg print x over here, right? So there we go. We have the hello world and we have 1, 2, 3, and this like works generically. Should do an animal example for shape. I don't know. What's the good example? Animal is the example of the object-oriented programming, probably, right? Where we have the inheritance. We don't have inheritance. We just do the generics. So this is working through the interpreter, and then I can do like target.js. This would work through the JavaScript. So we have the same stuff. And then over here, so this X over here is of type generic type string, and this over here is of type generic type int. But if you want to pass in a vector of 100 integers, right? Sure. Let's say like field. So I call this array list for now. Field is sure. Let's do something with the array. Let's do a more complicated example. Why not? So we like basically pass it a single value, and then we want to like duplicate it 100 times to create a list or something, or not 100 times. Maybe like let's just do 5 times. Okay, a lot of this syntax is too verbose at the moment, but that's okay. Yeah, so like these generics, they can be removed because this is inferred. It doesn't matter. Right? There we go. So now we have 5 hello worlds, 5 1 2 3s. Right? Does that answer your... I mean, I don't know what your question was about, but... I mean, you can do it. It's just like generic code. You want to do whatever. What if you pass the concrete vector? But what is the question? Like, what do you expect there? I mean, yeah, you can like have over here the array list of t's already available there, and then you just do field here, and then like over here you say hello worlds. I don't have like the short syntax for like initializing this thing directly, and I don't have fixed sized arrays, only this like dynamically sized one. So we do this result push hello, and then push world, right? And then over here we have like numbers. Let's say that it's going to be like 1 and 2 and 3, and this over here is going to be like numbers. In this case, I do need to specify the type somewhere. I mean, I can specify the type like over here, for example. Or I can just specify the type of one of the integers. Right, and this should be hello world. Right? So you pass the reference. Where do I pass the reference? No, I don't pass the reference. Well, that's not how it's supposed to be. It's supposed to be passed by ownership. Like, think of like Rust, for example, right? We are supposed to have the same semantics as in Rust. So we pass the ownership of numbers from this here to here. If I want to pass the reference, I would do it explicitly by reference. I don't pass an address, no. Well, I mean, when we when we compile this down to this stuff, then yes, anything that's generic is going to be passed by address because we don't know the size of the type, right? But but this thing could still be allocated on the stack. It doesn't matter, right? Like, I don't know what's the question about exactly here. There's a lot of like happening here. This is too complicated example for what I wanted to try. I'm going to move it back to just a single field of type T. Like this, right? Which is what I'm writing in C and JavaScript right now. All right. So yeah, right now, like this over here this is my language, right? But this is currently compiled. So we have the two backends right now, the interpreter and the JavaScript, and I'm working on the new backend, which is the minicast, which is the interpreted language, which is going to be transpiled to JavaScript like further. And then we can have another backend, which is like C, or I'm planning the Go language to be the next backend. Because it's going to be easier to implement the new backend on the simpler language than on like this thing with generics and compile time evaluation and macros and all of this shit, right? So right now I'm figuring out the generics, and I want to handle my generics without monomorphizing them, because monomorphization of the generics, it's compile times. When I was writing my language in Rust, my compile times were a minute in debug builds, and they were like that because it's not the code size, it's compile time. Well, I mean, maybe it's like the problem in Rust, the way Rust monomorphizes things. Maybe like it's doing like all of the other things. Hello, Cafe Gamer, by the way. Thanks for the raid. But yeah, it's because we want to save on compile times. It's not about the code size. Well, I mean, code size is also a thing, I guess, right? But it's mostly about the compile times. It's linked together since they copy multiple functions of the functions and inline it. What? It doesn't matter that it gets like some of the functions can get optimized, inlined. Some of them can be deduplicated because like the monomorphized functions can like basically look exactly the same in some cases, right? But it doesn't matter. What matters is that like before that optimization happens, before the inlining happens, there is like more work that needs to be done by the compiler, which hurts the compile times a lot. Which is why we don't want to do monomorphization, like at least in the debug builds. So the idea is to have the debug build, which is like compiling fast, versus the release build, which is when we do monomorphization and like all of this stuff, which instead runs fast. It's a trade-off. And also, I think similar to how like I'm also like having this idea that we can do basically like just-in-time monomorphization. You know, similar to just-in-time compilation, you can like monomorphize in the background and use the monomorphized version if it's already like compiled, basically. You know, I think something like that should be possible to do. And then the debug builds are also going to be fast in theory, right? Well, I mean, this one, this like existentialization technique is supposed to be fast enough because that's what Swift is using, and Swift is supposed to be the fast language. Anyway, right? Like Swift is considered a fast language, and they do not monomorphize. I mean, they do monomorphize, but not everything. Right? Here's what they say here. First, the monomorphization implies the definition of a polymorphic function may potentially be recompiled at each of its call sites, which severely hinders separate compilation and works against binary compatibility. Oh yeah, another thing is binary compatibility, right? Because like how do you make the function which is generic to be a library, which would do like in language like C++ or Rust, you cannot dynamically load a generic function, but in Swift you can, right? And yeah, which is fast. I think it's considered pretty fast. Yes, I don't know, but yes, Swift performance. I mean, it's not like Swift is not the language with zero cost abstractions for like they use the reference counting, which is automatic, right? So like it's not as low level as C, I guess, but it still is pretty fast compared to a lot of the languages. What about like Swift like versus Golang, for example? Swift is better at raw compute speed. Anyway. All right. So get field is supposed to return a reference to any. Return get as a function which returns this. Set is a value object field name as value. So we don't have references in JavaScript, so we represent references as getter and setter pair. So we have the generic function, and then I want to have the field of the result. Well, the result in this case is just me allocating this object. So we are trying to get the field of the result called generic type of t fields 0, right? The first field of this. What's the result? Result over here is just going to be empty object. That's a little bit different from what we're doing. And then mem copy instead means that we are saying right, this is the result field is this, and we say result field dot set to be the field, right? Instead of mem copy, we return result. In main, we are going to say that type. So we will have generic type of int32. No, this is just type, right? Type. Generic type of int32 is generic type of int32. And then we call generic function int32. And the field is like 1, 2, 3. Like this. Okay, does this make any sense? So we need to like unify this. So first of all, in C, we don't return. Instead, we have a pointer to the result, and the result is allocated on the stack by the caller. But in the JavaScript, we can just like initialize it like this, right? And return it. I mean, we can make it like more uniform by having a reference to the result in the form of a setter, basically, right? But that's not necessary. I think we can do this conversion automatically because this in minikast is going to be called the any type, and we can only return the any type. Oh wait, but it's not like any, right? Like this returns any, right? We need to like still know the size of the object here. Yeah, how do I like specify this? because I still need to be able to allocate, right? Here, saying the size. It's like abstracting over both C++ and JavaScript too difficult, and we should. And I'm trying to do something wrong. Right. So like, if we want to convert this 1-to-1, we don't return any. You need stack a lock in JS now. Yeah, like I need. I don't need like to stack a lock in JS, right? Like I want to abstract over both of these with my language, right? But if I like say that we have the any type like in the JavaScript here, then like how would I compile that to C basically, right? Like how do I get the C version from the JavaScript version, right? That's not possible because we need to figure out how to allocate this, right? So something needs to happen here still, right? But having a reference as the result instead of like returning the object would not be very efficient in JavaScript, right? So we don't want like the JavaScript version to also be like completely inefficient. I mean, it is already like not very efficient because like of the way we're doing the references, right? Obviously in C, you just get the pointer to the data, but you cannot do that in JavaScript, which is why we have the references, the reference, which is just a pair of getter and setter, right? And this already is a lot less efficient than C, right? But we want to not do that too much, if that makes sense, right? Actually, like the references could be implemented in a different way. By the way, we could also like have an object with a field inside of it as a reference, right? But then it means that I need to basically automatically box all the values. But yeah. That's also the implementation detail which we want to abstract over technically. So like the minicast still has the concept of references, but how do we represent the references in JavaScript is like a question, I suppose. And I mean, eventually I want to probably get rid of the JavaScript backend, just like it's a temporary one. So maybe it doesn't really matter that much that it's not very efficient. Maybe in this case we actually do allocate it here on the stack, right? So we say that X is. So let's just create the alloc A, right? Generic size of int32.size, right? But in JavaScript, I will just have the function alloc A, which is just going to return undefined, right? Like so what happens if we have like nested structures, right? Structures are represented as object in JavaScript, but if we have a nested structure, then we need to like initialize the nested structures too, and that is not like, yeah, because like there's, so like allocation is technically doing nothing. That's what I'm saying here, right? Yeah. So then we have a generic function, and this would like have a reference to X, right? Get returns X, set is value, X is value, right? Like this is what I want. So generic function has the result, and we have parameter result, which has type reference to any, and we don't return anything, so we return void, right? This is difficult. Maybe you should give up. Maybe. Are you joking? We never give up. Um, right, so we don't say like let result. Result is this thing, right? So we get field of the result. Maybe like let's try to like actually do it one-to-one. So object is also like a reference to something, to any, right? Yeah. We just don't need to like the references to the fields because they already passed by references, but yeah. So in JavaScript, get field would just be like object is object get. Wait, actually, like we cannot do it like this. We need to probably like get like that. Allocate. This takes the size. Returns any. Param size is a number, which is not used here, but that's okay. All right. There's no shorthand syntax, but this is how we create a reference to X. Well, I mean, if this returns a reference, hold on, should allocate return a reference? Actually, should allocate a return a reference, because that would be like literally a one-to-one. And then we have the let value be undefined, right? So yeah, and this is how we create the uninitialized thing. Reference to uninitialized thing, right? Get is return value, set is a new value, into value is new value. Yes. So the size is ignored in the JavaScript now, right? So this is like one-to-one. We allocate, and then we call the generic function. Yep. Generic type. And then this implementation could be different. Well, shouldn't the field be also like reference to any? Field get. So this would be like a reference. Ref to const 1, 2, 3. Function ref to const value. Turn get value set value throw error read only, something like that. What happens if you remove its set? That has the effect. It's going to not type check here, right? Because I set the types. I mean, I can make like the references to be the things with like optional getter, but like I don't know if I want to like differentiate in this one in like my intermediate language between the read-only references and mutable references. We do have that in the main language, right? But not here. Does C have const pointers? I think it does, right? Can you do like a const? Yeah, you can actually. So maybe we could. I don't know. Maybe we could. And then we would have like the different. Yeah, we'll have like ref and ref mut. But yeah, then I would not need to throw the error here. Dun, dun, dun. What is sheep in Russian? Why? What does sheep have to do with this? Oh, mut is like mutton. Reminds you of the sheep. I don't know. Are you making fun of me pronouncing it as mut instead of like how do you pronounce the mute? Mut, mute? Because of mutability, not mutability, right? So this is like almost one-to-one, right? We still have the like definition of the generic type, and like the types are passed by references, which we could do here, of course, right? But the issue is how do I get rid of this indirection? Like can I without much work make the JavaScript actually return the value? Because in JavaScript we can, and we don't need to know the size of the things. Oh yeah. Also, by the way, right? By the way, this is not it yet. This is not it. Can I say like over here main? And can I do like node calculator source.js main, right? Like this. Can I set properties of undefined setting field, right? Because over here I say that allocate returns undefined, right? But we need an actual object to specify the field of it. So here's what is missing here. I think that like we also need, in addition to allocation, we need to initialize the memory. Although initializing the memory is going to be a no operation in C, but it's going to be the operation in the JavaScript. I mean, at the same time, the initialization could like zero the memory in C, or like just for a little bit of more safety, but it should be a no op. You know what I mean? Because like I cannot just like create the object here directly. Well, I mean, no, I can. I kind of can. But then I need to not only know the type, I need to know the like, you know, like the inner structure of the type too. It's not only the size that is necessary in JavaScript, because we need to initialize the inner objects too, you know? stack alloc is kind of free since you just change the constant used by which is you change the stack pointer. Yeah, no, I understand, yes. But it's like, this is not free in JavaScript over here. Because I create these closures to basically mimic the reference. And that is not very efficient, right? But at the same time, we could have the reference. I could have a different definition of the reference, right? Let's have a different definition of the reference, which is basically an object which just has the value of type T. That's another thing. That's another way to do the reference. So reference T is just an object, which is, the objects are passed by reference in JavaScript, right? Which has the internal value. That's another way to do it. Right? So then we would have basically the function like dref, right? Which we don't need in C, which is, let's see. So this would be like a template T param, the reference parameter reference is of type ref T, right? And this returns T, right? That's what we want here. Well, this should be like called, I guess, readref. A function whose type is declared is neither undefined, void, or any must return a value. Yeah, that's right. So over here we say like return ref.value. If we use like this version of the ref, and then we want to have the function write_ref, right, which is taking the reference and value, and then it says like ref value is equal to value. And so over here we have another param value, which is of type T, and this returns void, right? Yeah. And with the ref2, if we use the ref2 here, right, then we instead say ref.get here. And over here we say ref.set. I think that like making the object is more efficient, but the problem with the objects is that like then every object that potentially needs a reference needs to live inside of an object. So I have been doing the closure because with the closures you can actually capture the references to like primitive values, not only to the types which are reference types. Yo, hello, Athena. So this would be like alaka2, which returns ref2, and then we have like the alak actually, which returns a reference. So this just returns, you know, value is undefined, right? Like this. And then get field is, oh yeah, that's right. I cannot have the references to fields in this way if I have the object, right? Because reference to field is not just the object, it is also like how do you reference a field? Because with the closures it's actually obvious how to do this, but with references represented as like objects with inner value, it means that the field reference is actually going to be the object itself plus the name of the field, right? So it's yeah, it's more complicated. Okay. Let's do the other way. Yeah, let's actually get rid of it. We don't have read ref, write ref, whatever. We don't have this. This is going to be called ref. We don't have write ref, read ref. Yeah, I don't think I can do it. We must use a closures, I think. Or like there's otherwise there's going to be like too difficult like to do it, I think. All right, but what we need to do, as I was getting into, right? When we have this generic function, this technically should return the result. I just give it the pointer to the result, but this reference is the reference to uninitialized data. So we need to initialize like the basic struct in JavaScript, right? So we basically need to say something like result set to empty object, right? Before we initialize like the fields here. So how do we do that? Right? I think we need to basically initialize. Well, and this is like the type. Type should know how to initialize it. Well, yeah, no. Imagine a programmer with 20 years of experience and never wrote a line of code. They only either modified or removed one. They have a -1 a million line of code. Well, when you modify, you technically like delete and then add a new line, right? According to something like Git. Yeah, so over here, since this is an object, I need to like initialize object result, right? Yeah, so we will have the function initialize object, and this is going to be reference set to empty object, right? And this is a function returns void parameter ref, which is a reference to anything, right? So now we do this. Let's console log x here, x.get, I suppose, right? Yeah, see, so like this is what we're doing. We are initializing the object with field being 1 to 3. So we have succeeded here. I never tested C, by the way. Can I like printf like %d/n and then like well, if this is a void star, then we like cannot do that. But does C have classes? No, it has structs. Well, I mean, this over here is the generic type of int32. This is technically does not need to be done like this, because we like if we want to have a little bit of them. right? Like we can actually use the monomorphized type here when we say type def generic type of int32 is a type, right? Yeah, so over here we have the int field, right? So it's supposed to be like this. So since this is the yeah, since like over here we don't have any generics in any like unresolved variables, we can use the actual type, and we can say generic type of int32 x, and then we say like reference to x here, and this could be like void star like that, and then we print f use /n in printf, not b. No, I just misclicked. X.field. Like this. One, two, three, right? This like depends on the fact that the representation of the in-memory of this type corresponds to this runtime representation which we are constructing, right? So we should be careful when doing this in C. So then I don't need to do this in JavaScript like that, I suppose. We say that we also actually have this type, right? We want to type def generic type of int32, which is object with property number field, right? So we want to say generic function, and I want to construct a reference to x, ref to x. Ref to x is of the type reference to generic type of int32, right? So this is get x that value x is value, right? Where we now have type like the actual value, which is generic type of int, which is x, which is the object. Okay, but we actually don't initialize it here. Yeah, we actually say like undefined here. As do you do as any, or like how do you like cast it here? Is as a keyword? Type assertions can only be used in TypeScript files, right? How do I like? How do I do a cast? JS doc cast You can cast or assert a type by writing a value in parentheses and placing a type. Oh, like this? Type any. Can I do that? Oh, I need the parentheses though, right? There we go. Well, I mean, I can cast to this type directly, but yeah. So over here we don't do x get. We say ref to x dot get. What is the type system in the comments? It's called JSDoc. Which lets you write JavaScript but still have the types here, which are understandable to the language server. And you have like the errors. You can type check your JavaScript, which is not typed normally. But using TypeScript directly is better, in my opinion. So what does this all mean? What does this all mean? Now we go to the minicast over here. And we want to construct the same example in the minicast, which is going to be transpiled to both JavaScript and C. Right? Let's move this here. So we have a generic type. Okay, we have. Let's actually do it all from scratch. It's okay. This over here is the original Kast code, basically, right? So we need to say what is the type. Right? So type has fields, which is a list of fields, and it has size, which is type size. Type size is just integer. Sure, we will need something like a size t probably. We have field, which is a struct, which has offset. No, it's not offset, right? So like this depends on the backend actually, right? Yeah, so we wait, but we actually know the backend here, so yeah, but I want to generate different code actually based on the backend. I kind of want to generate the same code for the most part, right? So what do we do here? It's just like the offset, which is going to be a different type. Maybe it's not like offset, but like something. So we do either an offset or like, yeah, let's call it, what's the common name between the offset and the name? You know? So this would be like the only line that is changing between the JavaScript and the C, right? It's in like the integer or it's a string, which is the name of the field, right? Well, I mean, also technically we can make the okay. Actually, is it more efficient in JavaScript to have your objects as objects or as arrays? What do you guys think? What is more efficient in JavaScript? But I mean, I like for the debuggability, we want them to be objects anyway, right? But let's actually try something here. Let's try something. Test JS, right? How about this? We want to create like a bunch of objects, right? Function create, and this will return the object, you know, like, yeah, arrays are direct access, objects are hashes, right? So like, because like I already like have the information about the fields, I could represent them as the indices, right? And that would also be the offset in this case, right? Even when we do to JavaScript. So let's say over here, let A is math random, let B is math random, and then over here I return A and B. They do something like this, and then we say that let A is empty list. No, not empty list. Let's say let, like, I don't know, sum is 0, and then for I is 0, I less than 1,000,000, I plus plus. Let object is create, and then we like sum plus equal object 0 times object 1, right? And then we console log the sum. Right? Is this going to be optimized? Going to do 1 billion? 1 billion is too much, right? Should be 10 million. Maybe like 100 million. Right? So this takes hyper fine calculator source JS test JS. Oh, JS. Oh, it's because the calculator is not here. Until I can install Node.js directly here. Otherwise, it doesn't see the alias, right? Right, so there we go. It's like 1.8 seconds. I mean, probably like it's because of the math. Maybe I should like do something else so that I can actually, I mean, let's try this, right? Let's try this function, create 2, right? And this is going to be an object with A and B fields, right? And then over here, we say instead of this, we say object.A times object.B, right? So the question is, this is still the same time. I feel like this is being optimized, and we will not see the difference. Right? But anyway, this might be a more efficient representation. on a more complicated example. I don't know how to do like the one where it matters. So yeah, let's call it the offset, which could be like a name, right? Field, offset, or name. How about this? Offset or name. Let's just call it literally like this. Offset or name. Right? And then we also have for the field the type. Which is going to be the type. And technically we need to go through the indirection here too, so we're going to do the reference, I think. Right. Okay, then we will have const int32, which is type, which is fields is just an empty list. And size is, well, the size is something that does not matter. Right? I feel like we should like not call it the size. We should call it like shape, right? Which like I don't know, and then we will have some built-in like shape of, and this is going to be a built-in shape of int32. This int32 is the built-in, right? Like let's call this int32 type. Let's call this type. Like we want this type info, right? This is run type info. Int32 info. Type info. There's this. So the shape of is like either the size of in the C, or in case of a JavaScript, it would like allow me to initialize like the object so we can have the references to them immediately properly, right? Which means that we don't need to like initialize the object, and instead we do it literally when allocating, right? So it's like based on the shape. I think that makes sense. So then we have the function get field. So get field should be the function which takes the object and the field returns. So this should return the reference, and we do have references to something. All right. So we have the this over here is going to be the field. Let's call it field info. Right. And the object is reference. So this over here is going to be reference to any, which is a void star in C. And this should return the reference to any also. Right? And this over here is the implementation that is like based on the thing. Based on the stuff, right? So this is going to be a type. Yeah, we don't have like this. Yeah, we have the shape, right? Which is type shape. So I have type shape, right? Which is So we have a struct basically which has size like this. This is like in C, and then in JavaScript we have the type shape, which is basically kind of difficult to make a programming engine in VS Code, but good luck. Visual Studio better. Huh? What? No. What? VS Code is literally Visual Studio Code. What makes the Visual Studio better compared to VS Code? Also, this over here is NeoVim, and if you want, I can also open Helix over here in the bottom, so we can have all of the different editors available to us. Because why not? Okay. VS Code. I mean the Visual Studio, the one that is not the VS Code. Meh. I don't have it. Wait, is it actually working on Linux these days? Visual Studio Linux. They do have it, right? Just missing ED. So type shape, this is JavaScript. This is like C, right? TypeScript in JavaScript would be what? Like basically, what do I need, right? What like type shape is what do we need to allocate the type, right? Maybe we call it the allocate info or something, right? Which in C, in order to allocate, we need the size, but in JavaScript, we need like Gamer 178 with all the AI hype going around. Should I start learning AI and all, or should I continue my web dev learning and finish it first? No. I don't know. Yeah, we have call this the allocate info, right? Allocate info. Allocate info. So yeah, the allocate info. And yeah, and so the allocate info is actually going to be the built-in then? Similar to the size of? Should this type be a built-in then type? Should the function allocate be a built-in type? Maybe. But in JavaScript, we want like we want an enum of the you know, like we either allocate the object or like it's a primitive, right? And if it is an object, then I need the fields, right? Yeah. Maybe we can do like something like this. Struct, you know, is object, it's a boolean, and then like the fields that we need to allocate, basically, right? Well, but then over here we have like the fields and stuff, right? So we already kind of have that information. The allocate should work on the type information, right? So we don't need any extra well, allocate info is just is object, basically. That's all that we need, right? So the question is, how do we allocate, right? So allocate type. What's the definition of this? Right? It should actually have the type info as the argument. Then, right? And this should return a reference to any. Which would be, so this would be just the built-in function. Because like I cannot have the allocate be called through the indirection, right? Or can I? Can you do it in C where you actually can you in C have a function that returns something allocated on the stack? Or like is allocate a magic one? Actually. Here's the C, right? Let's see, allocate. Right? It is a built-in allocate, the size, right? Like as soon as when the calling function exits. Well, I mean, it should be possible to do that, right? But it would probably require some assembly to work, right? Because like normally the return thing is the return place is stored on the stack, I think, right? Too. So we need to get rid of that, and then allocate the object, and then put it back, and then return. Even in assembly, it makes no sense. No. Like, what's the calling convention? Like, isn't the last thing on the stack the return? The return thing, like when you have in assembly x86 ret instruction, right? Like this is just popping the stack, if I remember correctly. There's a near return, a far return, an interpolated far return. But I think normally it's just stored in the top of the stack, right? The address where you return to. And so like it means that in order to write this function, you need to like take that address out of the stack and then like allocate the object, put the return address back, and then return. Or just jump to that address. I guess would also work, I assume. So yeah. It's probably like possible to write that in within line assembly, but then it's like target dependent. Maybe you cannot write something like that in C. So the allocate is like the only maybe like built-in thing which can allocate stuff on the stack, right? Can you write a custom C function which allocates on the stack of the caller? You cannot write a custom function that allocates memory on its caller stack frame using typical syntax. When the function returns, the stack frame is destroyed, right? You can achieve this behavior using the compiler intrinsic. So it's the intrinsic, right? It's magic. And then you could do a macro instead of the function, of course, if you want to do that. Allocate also allocate will not work if you call it inside of the like function, right? Which is why like you must call it in the function in which the thing should be. Yes, it has to be a macro, of course. I'm just saying that like we cannot have a function allocate type, which we would call like allocate in C, right? Because this should directly be like this like must be inlined. Maybe we could have an annotation which like must inline or something. I don't have the annotations yet, but like this is the function that has to be inlined basically, right? Wait, does C work? Wait, hold on. C only allocates the stack like once, right? So if there is like multiple branches, it doesn't like allocate on this. It doesn't push this like increase the stack pointer or whatever. When you like open the scope here, right? And you have like int x inside of this scope, or is this x like and like this x? Is this going to be a conflict? No, like you can have like scope local variables, right? So my question is, what's the lifetime of this variable in C? It can increase it many times, it's fine. No, so what I'm wondering then, if it can increase it multiple times, then the question is, what if I do allocate in this scope, right? Like, after I exit this scope, does it actually move the stack pointer back or not? Like, what's the lifetime of this object and what's the lifetime of the object returned by the allocate? Because they say that it's like will be freed when the calling function code, right? So shouldn't this be the same for the local variables too? I mean, documentation specifically calls the calling function, right? Not the scope. Yeah, I can check, but it can be like different in different implementations. So I'm wondering what the standard says, I suppose. Are you sure that it will increase this stack pointer multiple times, or maybe instead of doing that, it increases it once? It like calculates the maximum size of the stack that is required for any code in the function to call. Like maybe it actually does not do the the increase the stack over here and then decrease the stack and then increase the stack here and then decrease the stack. Maybe it doesn't do that, right? It just says that this is the offset. This is like it just increases the stack size here that is required for the function to run. It increases the stack size here and then decreasing the stack size and then like calculates the maximum stack size at any point of the function call probably, right? And then this variable just exists at specific offset from the beginning of the stack frame of the function, right? That would also make sense, right? Probably makes more sense than like moving the stack pointer all the time. But it means that in some specific cases, right, like if I say over here int 1000, right, it means that when I'm calling the function here, I technically have allocated the stack for this variable too, which would be a waste of memory. So I don't know if, but that's probably what C does still, right? Does C always allocate stack memory for all variables in function, even if they are not going to be used. If you don't waste the memory, then its calculation gets a lot more complex for the stack indices. No, I don't think so. No, C compiler does not always allocate stack memory for every variable in a function. Modern compilers use various optimization techniques that can prevent unused or redundant variables from ever occupying the stack. Oh, well, this is not like what I use, and like stack reuse and stuff. I mean, this is the job of the optimizer, right? But like semantically, it's basically still allocated on the stack, right? So, like, my question basically is, you know, if semantically, where does this allocate semantically? Right? like this over here is going to be like, you know, if some condition, right? So we don't always need this 1000 like bytes, I guess, right? Of stack is what I mean. So in this case, the allocate function is the function that should allocate in different places, right? Semantically, you cannot assume the stack property of the stack allocation that happened in order. Yeah, I don't know. Maybe like because this is a built-in like we don't need to think about it, right? It's just supposed to work somehow. We don't know exactly how, but it's supposed to work. That's the important part, right? Hello, Ray March, by the way. What am I worried about again? I don't know. I was worried that this could lead to miscompilations because it would like pre-calculate like something. I don't know. I don't remember anymore what I was concerned about. All right, so we want to allocate type. So this is in like so in case of C, C, this must be inlined then. We just use the alloc A, which is type info. Allocate info size, right? Like this. But in JavaScript, so in JavaScript instead, we say something like if type info allocate info is object, then we do one thing, and otherwise we do the other thing. Right, it would be like return. I don't have returns. Should I have returns in the minicast? I don't know, maybe. So over here we return undefined. We like literally uninitialized is what we have, right? And we return a reference to uninitialized. You can stack allocate them using the same syntax as JavaScript variable declarations. No. Because when you declare a variable, it becomes so uninitialized would like transpile to undefined. But for objects, in order to get references to the fields of objects, I need to actually like initialize it. You know what I mean? When I'm allocating, otherwise I would not be able to have the references to fields. All right. So allocating involves like the creating the structure of the object. So if it's an object, then I need to say that like struct foo bar is 0. You can still visualize it though. What, in JavaScript? Yeah, I can. But like this is a generic, like we're trying to make an abstraction over C and JavaScript. Which is like low level enough to make my C efficient. But I specifically don't want to initialize them, right? Kind of like, because that would be inefficient. In C, I don't want to initialize. So allocate should technically give me the uninitialized piece of data, right? Reference to uninitialized thing, which is why we like, and we'll allocate like on the stack like this. But we don't want to initialize in C because that is hurting performance, right? We are initializing like using the other code. Yes. But we cannot do struct full bar always, because we like, okay, and then maybe you just came recently, right? We are trying to understand how to compile generic code. We already do this, what you're saying, for the non-generic code. But when the generics are involved, we don't want to monomorphize, and that is the challenging part of it, right? How do we do it without monomorphization? And that is why we are having this like type description here. So we have the run type information, which specifies how to allocate the object. Because then I can not just say struct foo bar, because there is no definition of the struct foo. Then wouldn't you have a C struct for the universal layout? What's the universal layout though? No. If you want like to have the object, like dynamically typed object, then like it means that it would need to live on the heap, the one layout rule them all, which is like what like JVM is doing and stuff like that. That is also something that we don't want to do. So we don't want to monomorphize, and we don't want to do like boxing of every value, right? We don't want both of those. So like this is what we're doing. Existentialization is what Swift does for generic code, where we do allocations on the stack, and we don't box every value. We instead compile the generic code, so it's like this over here, generic function, right? Which takes in the original code over here the generic argument t, but when we compile it to C, we convert that generic argument to the runtime argument, which specifies the layout of the type t, right? Instead of having this being a boxed value. So this is a pointer, but this is a pointer to potentially a value on the stack still. Is a struct on the stack considered boxed? No. No, box is like when you heap allocate. I mean, yeah, I think. Is that the definition of the boxing? I guess, right? Yeah, we don't want to store the values on the heap. We don't want to allocate too much. Which is why we allocate on the stack, which is like making this thing fast. Right. So so in JavaScript we would have the type info like this, and we say like result is, so in this case we would say like native empty object, and I guess this also is like native allocate, and this is like the argument, right? Yeah, that's what we do. We don't do mutability in minikast at this point. Boxing was when you pass the pointer around, is not the whole object. Yeah, maybe that's the definition, but yeah, we don't want to allocate on the heap. 1 second. So yeah, so if it's an object, we need to like create the object here, and then we need to like also go through all of the fields, right? So we need to say for field in type info fields. Oh wait, we don't have a yeah, we don't have the for loop, right? Wait, how do we do the for loop? Do we do like, hold on, how do we do the loops? Do I need to like a dedicated loop? Maybe for with indices, right? Is what we want. I can have a while probably. Um, like what's the minimum amount of built-ins that we do? We do have the unwinding, but I think maybe we do actually the proper for loop. Well, I mean, iterating over a list, maybe iterating over a list could be the thing. I'm not going to like generate this though in other places, this code. So you know what? This is the like this is JavaScript specific. I don't even need this to be built into the language. So I say native, right? Say native for let field of type info fields, right? And over here we need like to you know, let's just say over here let's just say over here setup field with field, right? So I need to not escape the field because that's defined here, but setup field should be like the function here. Oh, but I need to like call this function. It means that we define the calling convention, like we depend on the calling convention here. I want to like depend as little as possible on the implementation. Like okay, I mean setup field undefined and field like this means because the calling convention is we have the context object as the first argument and then the actual arguments of the function. Which by the way I could do the opposite order and then it would be like easier since I don't know. So we just say setup field is field, which is the field info. Right? And this would say, well, we still will need to have the thing which is called the field. right? Generic function. Yeah, we need to like we still will need to have the function called getField, which is supposed to be the object, which is a reference to the object, and the field, which is the field info, and it should return the reference to the field. Right? Yeah. So we need to get field of the object, which is reference to any. So we need to have a reference to the result. And this must be type annotated, by the way. So, but the type here is any, I guess, because that's what we return. And I will return the reference to the result because that is possible in JavaScript to return a reference to a local object, right? We do this. There's a get field this and field. Oh, we don't do my reference. Okay, sure. We say get field, and this is reference to any, and then we like dereference. No, we don't dereference. Because we need to basically not allocate, right? We need to set this up. No, we need to like say get field is allocate type, which is the field type. Also in a camel. Yeah. Wait, how do you return a reference to a local object in a camel? Let's say that I was transpiling to a camel also, right? So like in Golang, you literally just return a reference, right? In OCaml though, I would need some trick like the like how do we represent references in OCaml with a ref? But this is the same as like it means that everything that I referenced should be in a ref in a box. I tried this earlier with JavaScript, and like how do I reference a field then? It means that every field and every structure should also live inside of a ref, right? So I'm not sure if ref is how we do it. Maybe we would transpile to OCaml by also having the references represent as closures with getter and setter, which is cursed, but you know. I don't know. Otherwise, I mean, we basically need to do like escape analysis, like the Golang does, I guess, to know if we will need the like I don't know something. You know, we need some analysis to know if I need to like create the object normally or like not normally, and then like I don't know, and every type, every like field. Wait, how does it even work? Wait, how does it work in Golang? Golang reference to struct field. How does this work? Anyone knows? Because Golang is garbage collected, but at the same time you have a reference to a specific struct field. And this creates a pointer directly to the field's memory location, right? Is that true? Or are we still holding the reference to the entire struct? So maybe is a reference to the struct field actually a fat pointer, which is the pointer to the struct plus the offset, right? So this is of type star int, which directly modifies this. But how does this work? Go's garbage collector tracks these internal pointers. Even if the main struct variable goes out of scope, the memory of the entire struct for the entire struct remains allocated. Right? Yes. So you can leak memory like this by holding references to the fields of big structs. Right? You can only take a reference to a field if the struct itself is addressable. Non-addressable. Values returned directly from a function or map elements. Oh, wait, you can actually not take the reference of any value? Oh, no. How do I have a references to the fields? I think I will not be able to transpile to Go. So you cannot do this? Oh, no. So we need to, like, represent the references in Go as, like, sometimes for the maps. Wait, does it is that true? Is that true? Let's go to Go. Can I have like A is make map int, right? And can I have like a reference to A? You know, like ref to A is this, right? So this just declared is not used. So can I have a reference to A123? Invalid operation cannot take address of A123. Oh no. You actually have unaddressable things. What happens if you have the structs over there? Are those going to be garbage collected? Like if I have type foo struct value int, right? And if this over here is the foo appendix expression of type foo, yeah, we cannot do this. And like dot value, we cannot do that. Oh no. Okay, well, I mean, it means that inside of the map, we should always get the pointer, right? And then this works, right? Then this works. You just cannot store the direct things if you want to have references to them. And like, what do I use the maps for? I want to use them for some things, yeah, but for those things that I want to use them for, maybe storing the pointers there is okay. Yeah. Get field. All right, so we get field is allocate type this. Yeah. So yep. What did the existentialized paper do for fields? I don't know. You think it did not do the same stuff? Yeah, you have like the vector of the members. Well, I mean, you just have the types because that's all that you need, right? So you need to specify how do you drop it, how do you copy, and what's the members, right? So field technically only has the types, right? Wait, but how do you calculate the offset? I need the offset for what? To get the field at runtime. Yeah, the question is how do you get the fields then at runtime, right? If you don't store the offset here. Well, it's because for the generic things, you Wait, and why is this needed then? Why are the members even needed? Like, basically, you could have it be based. No, we still want to like access the type, the fields directly, right? If we have a generic type. Like these examples though, they don't have the things where you access a field of a generic type. I think so. Right? Because you only need like the implementations of traits in this paper, in the examples. Otherwise, it's like the same as I'm doing. I did not get to the dropping yet, but yeah. I did get the copy already. Well, it should be, maybe we call it not fields, but members, actually. List. Member info, right? Because this is going to be the information about the member of a union too. Type has size. Yeah, I have the allocate info. I don't do it just as a size, because in JavaScript, it's not the size, but a different thing. Right? I'm trying to abstract a little bit more. Using that, you can calculate the offsets. Yes, but like you don't want to calculate the offsets at runtime, right? Do you? I don't think you want to do that. Is there a thing called offset? And fields? Okay. To support changes to the contents of data structure provided by the library in a language using inline presentations, one must ensure that clients of the library do not emit code that depend on the specific particular memory. Instead, clients should obtain the information about sizes, alignments, and fields offsets at runtime, right? But like, isn't it easier if the field offset is already calculated for you and you don't need to like calculate it for every field at runtime? That's supposed to be faster, because like then accessing the field number 10 would require like 10 times more operations than if you have already pre-calculated, right? I think just like in these examples that I show in this paper, they don't like access fields directly of the generic types. Okay, so we have the allocate type, the get field. How do we implement the get field? The get field is going to be the right. So this is also depending on like the target. Do you think I should do like some form of the like conditional compilation in minikast? The issue with conditional compilation is that like we need to have basically a dedicated language to how do we select a specific branch, right? Like what exactly is going to be compiled, right? So in the main cast, we just use the interpreter to determine the branch. But over here, it must be a dedicated language. Like in Rust, you say like CFG, not Windows or something. And this is the language, which is like a custom language, basically. You have not, any, and stuff. Right? Which becomes like complicated. But I kind of like want right now to like just test the language without transpiling from cast to minicast. C style preprocessor macros. C style preprocessor macros. Well, I mean that's also a different language basically, right? Which would not be needed. But I mean, yeah. I mean, yeah, we could say like wait, how do you do like if Linux or Windows? So like in C you still have like this like Boolean operators at least, right? You have the string comparison operators. And like yeah, it's like a full language there. A very simple one, but still a language, right? What can you do with the C preprocessor? Right? Like there's a lot. Or is it not a lot? Well, I mean, you can define. So the important ones are define and ifs and if defines, right? And what can you have inside of an if is the question. Where's the documentation of this? Hello, Hisoka. C preprocessor spec. Top. This GCC GNU org is not opening. I can announce there's going to be a 6 more Ludum dares and then he's killing it. 6 more? That's 3 years. Right? Why don't you love us? 3 more years. Yeah, okay. Sure. Don't know what to think about it. What do you think about it, Brainoid? Are you happy or sad? You know what? Here's what we do actually, because we actually have in the in minicast. I already have the option to compile the multiple files at the same time. So how about we do this? We have like the C, like how about this? We have the runtime. The runtime for C MKS, and then we have the runtime for JavaScript. Yeah, we can do this, and then we like and then we do the things, right? Yeah, and then we can have, so if this is conditional compilation, we just do this in different files, you know. So this over here is going to be in C, and this over here is going to be in JavaScript, right? Maybe I can like said he's not passing it on to someone. Well, he did list some reasons, right? Did he not? Just says make your own one, right? So I feel like this does not make much sense. Well, he can, like, it can be like basically passing it to someone who made the new Ludum Dare, right? So he could like say, okay, well now you now the GMTK is the new Ludum Dare, or now like the D2 Jam is the new Ludum Dare, which I don't think will happen, but you know, that would be like the same as like passing it to someone else, just to a different website, right? Maybe. C processor expressions only support integers and character constants, so no string constants. I'm pretty sure you can like have the like isn't there like if like something is equal like something else, you just don't do the string quoting here, but like it's like compares the identifiers maybe or whatever. I don't remember. It's awful to say make your own Ludum Dare, but not call it Ludum Dare. I don't know. Maybe. Well, at least he is like not pretending to like want to run it anymore, right? Or something. And field offset or name is also dependent on the C or JavaScript. So field offset or name is just integer in C, and in JavaScript is as a string. Right? Now this is common. Member info, type info. So now the get field is probably just going to be done in C differently than in JavaScript. So in C, if this is a reference and this is a member info, so the member info has the offset, right? We will say native. We just need to basically say, so object, this is a void star, right? And we need to add basically the field offset or name. Like we just literally need to add it, do some pointer arithmetics here, and we'll return the new pointer. Let's not call it field, we want member. Not quite, that is why C has offset off. Well, offset, well, I mean, offset off is this. Isn't this, like, when you, like, this is, offset off is how we calculate this value, but once we have the offset, this is how we can get the pointer to the thing. I understand that C has packed structs. Oh, wait, you have packed structs like bit packed? And what would the offset off then do there? Well, I mean, offset off would just... Wait, what? How do you do the off... What's the offset off? Then. Offset off for packed structs. Offset off works great for packed structures. Return the actual byte offset to a member. Well, I mean, yeah. Well, that's the offset. Right? Because the offset by simulating the pointer to the structure and memory address 0, and then find the address of the desired member. If you pack a structure, offset off will return a smaller, non-aligned value that reflects the new compact layout. Pragma pack push 1 force 1 byte alignment. I mean, yeah. No, I mean, like, offset off is how we calculate this thing. This is the runtime information, so we don't have the ability to do the offset off. Is the problem, right? So yes, this is supposed to already like be the correct information. But how to obtain this information? That would be yes, using the offset of. So we don't like hard code that. But this is the run type information. So we don't know the actual type. So this is a void star here. And so in JavaScript, this would be object. And then over here we have member dot set our name, right? And we return the object with get, which returns this, and set value, which does this to be equal to value. And this should be like object, this is the reference dot get. Kind of like, yeah. Something like this is what we want. All right, allocate type is also depending on C. So in C, this must be inlined. How we do the inlining is the question. It means that maybe this is not a function. We should like have macros then. Well, I mean inlining, like, yeah, maybe we will have the attribute to inline. In JavaScript, allocate type is just this. Okay. Now get field we have, right? I mean, I might as well like put with this, even though this does not differ between the JavaScript and C. Because that's the runtime basically, right? Very small. Now and now over here. Oh, yeah, because yeah. And over here we are going to actually generate code, which is different. So what is the allocate info? Yeah, an allocate info, and this is going to be like a built-in allocate info. Maybe I do it like this. Allocate info of the integer and fields. I mean, should this be built in into the minicast or like? But then we could like query the type information of the like necessary structs too. So we can say like type info of the int 32, and then it would like do this thing for me. It's only for the generic types where we need to do it at runtime, right? Let's have the syntax for it. Mini syntax. Type info is type info of the type. Rebuild. So then we have the generic type as a function which takes t as a type and returns the type. Why does this not work? Why does this not work? Kast mini parse tests mini generic, right? It is parsable. It's because it's for some reason kind of like restart language server properly, or I don't know why. Reload the window. I don't get it. It is definitely being parsed. Are you stupid, VS Code? If I restart it like this after killing it? No. Is it thinking for some reason that it needs to... Like, no, this like this is... It's definitely using the correct syntax. My VS Code broke. Maybe I could see in the output. I don't know. It just says that... So if I say like this, then it parses. But like this, it doesn't. And that's because it did not pick up the change of the syntax, even though I definitely changed the syntax, right? Like, it's like using the old thing somehow. Oh, wait a second. Wait a second. Hold on. What is my... No, it's... Yeah, it's running the Kast MJS. For sure. Seems like the... thing. This is my like Node.js for some reason is using the old version of it. There's no way. It makes no sense. Okay, let's just kill the language server. I don't know. Don't want to think about it right now. Let's not have syntax highlighting. We have generic type. Type info. Right? So this is where we need to... so there would be a to-do memorization, of course. But let's just construct it every time, right? So first of all, we need to malloc the size of type. So which means that we need to actually... and this basically means that we need to allocate the type. I just don't need to allocate it on the stack. Right? Wait, does it mean that I should in the runtime like allocate type? This should be there should be like two versions of allocate, right? On the stack and on the heap. Or maybe rather what we want... I don't know. There's like separate allocation versus something else. Let's just use for now allocate type t. There should be a reference, right? And this should also and this also should return a reference. By the way, right? So yeah, over here we say like to do on heap, right? Which means that allocate type on stack. Let's just call it on stack for now. You know what? We can have like two different things. Allocate type on stack and on heap, right? So this would be just a malloc. Allocate info size. This one does not need to be inlined. And in JavaScript, we say that allocate on heap is just returning allocating on the stack. Because there's no difference there. Okay, so we want to allocate on the heap the type t, right? And this is the result. So then we say that result. Yeah, and this, so this over here was a reference to any, right? But now we know that it is a reference to what? Oh, okay, yeah, and also we allocate on the heap, not t. We allocate the, we need to allocate the type info of the type info, right? type info, you know? So we have type info, which is of type info, right? Which is type info of type info, right? Like this. And so this is a reference to type info, which we are going to create. And then we say that result allocate info. So this over here is specific to the also, yeah, but like this is going to be generated anyway, right? From cast to minicast, I suppose. Allocate info. Dot size. So generic type just having the single field, right? Is it actually guaranteed in C that a struct with a single field? C wrapper. Well, I mean, unless you like do the pact, it's the C representation is well defined, right? Is well defined. C struct representation in memory. Is this is represented considering the block of bytes by field as stored in the exact order, right? So yes. But then there are alignment and like padding rules. Oh, but this is actually determined by the compiler and target architecture. So like there is no like fixed alignment. How do you interface with C though then? Or is the alignment and padding still like well defined for every architecture? Is very striking drag, you wouldn't worry about it? Like when you do in Rust repr C, like it should be able to calculate with the same rules, right? Which means that these rules should be defined somewhere. Modern CPUs are optimized to read data from memory of multiples of this data size. Yes, sure. Structure padding, internal padding, tail padding. Yes. Total size. You know of any architecture with known standard alignment requirements? But it's like theory. In theory, it's possible, or no? Or is this like part of the standard? That's the question. Struct's memory is laid out by the compiler. Oh, by default, right? The compiler can reorder data fields or pad additional bits between fields implicitly. Reorder fields? In C? No, that's not. There's no way. It is implementation specific, but in practice, the rule is this. So, is there no spec? So like the world is like just holding on the thing that is not specified even? Is that right? In C, the compiler is allowed to dictate some alignment for every primitive type. Typically, the alignment is the size of the type, but it's entirely implementation specific. Huh? Okay. There's only really one reasonable way to do it, given the constraints this spec places. Okay. I mean, is there like any architecture which is like doing it somehow differently? Well, I mean, it says that the compiler is allowed to dictate it, right? So it's not like, it seems like according to this text that um that it's compiler dependent, not target dependent. So there could be like multiple C compilers which compile it differently. Is that right? From C99, each non-bit field member of a union is aligned in an implementation defined member appropriate to its type. So like, what's the implementation? Implementation of the compiler, right? Not of the target. Which means that there could be like, you could compile the same code with different C compilers and you would not be able to interoperate. Is that true? Also, I have a question about the padding in the end. Right? Like, I understand that in order for the arrays to have proper alignment, you need to insert the padding at the end of the struct sometimes, right? But that's not necessary when you are creating a single object, right? So shouldn't there be like two sizes for every struct? One like which you would use when you are allocating an array, and one when you are allocating a single object, because otherwise you would waste a couple of bytes. Okay. C compilers can be platform specific, yes. That's not like what I was thinking about. It's like for the same platform, there could be multiple C compilers which are doing different things, do different layouts of the structs, because it's dictated by the implementation of the compiler, not by the platform. Swift does it that way, but C just rounds the size of a struct. Okay, so it actually is like, yeah. Well, I mean, you are not supposed to ever access the padding bytes in the end anyway, so you actually can do it like this, right? Yeah. I'm just saying that if we have this, the size information, it means that the allocate type should actually also be like, yeah, you know, if I want a little bit of the more efficiency, then we could have the allocate info is like size for array, and like size, like we can say like size without final padding, which is two different sizes, right? For a little bit of efficiency. So and then it means that we should be able to not just allocate a single one, but we should be able to allocate an array, right? Which is this. This stride in Swift is the length of C. Yes, that's right. It's actually called stride. I agree with that. That's a good name. There is a size and then there's stride. Yes. So when we allocate it on the stack, I guess like it's important for the stack maybe sometimes, right? Wait, hold on a second. Hold on a second. How are you supposed to do the proper padding on the stack though? Like, isn't the allocate function in C allocates the things based on the bytes? It doesn't take into consideration the alignment, right? Here. Why does the allocation... Wait, yeah. Why does the allocation not have the alignment as the argument, actually? In C, in general. It just overlines everything. And malloc also overlines everything. C, allocate, alignment. I mean, it is the intrinsic, so like maybe because like it's not even a function technically, right? Most implementations guarantee that the return pointer is suitably aligned for storage of any type of the object. Overalignment issues may not automatically satisfy stricter alignment requirements for overaligned types, such as 32-byte or 64-byte AVX registers. Yeah, like there is like this alignment for the SIMD stuff, right? Which would waste a lot of memory, right? How to manually align allocate. If you need a specific alignment, you must manually over allocate and adjust the pointer. Wait, is that like part of the specification? Oh my god, see so many food guns. Ugh. Yeah, you need to like understand everything before you can like guarantee that your code is going to work properly, right? What about malloc also? Like if I want to malloc and like do the SIMD, then you also need to over allocate yourself, right? Okay, well, I'm not doing C yet, but I would just like knowing things, I guess. I think SIMD eventually will be added to Kast because it's important for performance, right? So over here, I need to like specify how to do this based on like that, right? I think what we need here, since this is like returning a struct, maybe this could be done in the runtime, right? Like we need to say result allocate info is like yeah, like I need to specify the fields first, I guess, and then yeah. How about this? We say result result fields is, so over here we need to have a, I don't know, how do we specify the lists yet? And yeah, this is where I need to like allocate this stuff. And what is the list primitive? Should I have like the list? That is an interesting one too. Let's pretend that we have this. So we need to have a new field offset, right? Where we say offset or name. So in this case, we have the field, but the offset. Okay. Field, like, right? We have the field is the field info. Well, we have member info, right? Member field, which means that this is also members, right? And this is like member field. So this member info, which is going to have the offset or name. And this over here is dependent on the thing, right? Can I like initialize offset or name for the field? So like in C, it would just like make it 0. But in JavaScript, that would return, that would just like make this string be returned back. Right? So in C, we say initialize offset or name is a function which takes well, it always takes the string though here. This returns member or offset name, and this just returns 0. In C, right? But in the JavaScript, I will just return the name. So this over here is making this generic code. So it's initializing it, but it's initializing it incorrectly in C, right? Because we want then later to calculate the size and the offsets of the fields, right? Yeah. Which means that we want to calculate the allocate info, right? So we want to have something. Is the async stuff in Kast going to be based on the event loop implemented in minikast? No. No. Minikast is, I think, still going to be like async, and that is going to be like converted later when we do like transpile to C. You know, I think so. And like I said before, C we are planning to do Golang. So in Golang it's not the event loop. Right? It's the coroutines. And I think like in C, when I would transpile to C, I think we will do something similar to Golang with the coroutines implemented. So I want stackful coroutines, I'm pretty sure. And now there is like different implementations of that. I was actually looking into this thing where both Golang and Rust they were using like the segmented stacks before, but they moved away from it. Oh, you have segmented stacks in LLVM even? Wait, what? I thought you would need to like implement this from scratch. Wait, why do you have segmented stacks in LLVM? LLVM is like more high level than I thought it would be. What is this? Call queue more stack. But yeah, there is something special needing to be done for this thing for sure. Although I guess like there is one problem where like I guess in JavaScript it's all single threaded. In like Golang. I think you can like pin the coroutines to the threads, but yeah, I don't know. We'll figure things out. LVM was explicitly designed as dumping ground for research projects. So is like this actually being used anywhere? Segmented stacks on LVM. Like I know that basically the Golang and like moved from segmented stacks to copied stacks. So where when you need more stack for your coroutine, it actually copies the stack and then revalidates, like updates the pointers to point to the new memory. Because segmented stacks have like the problem with performance in the like in like hot split, I think, or whatever it was called. But I was thinking that like it can be fixed and we could still use the segmented stacks. But anyway, we will get to that at some point in the future. LVM is modular and encourages people to contribute their extensions. I see. Is there like a garbage collection then LLVM? LLVM GC. Oh wait, there is. Of course there is. Specified GC code generation. I was for some there's built-in GC strategies. Holy. Okay. For some reason I was thinking that LVM would not be having the garbage collector, but yeah. I didn't actually look at LVM, I guess. Ever. It literally has everything. Do they have the coroutines then too, right? So like then that's what you need the segmented stacks for, right? Well, I mean, maybe you use the segment stack for other things too. LVM coroutines, right? Yeah, coroutines. And are they like stack full stackless? Can you have like both versions? You have pre-split coroutine, coroutine transformation, multiple suspend points, direct save and suspend, final suspend, custom ABI. No, maybe I should consider LLVM instead of C then, because otherwise, because it seems like LLVM just has a lot of things that C doesn't, right? I don't need to build my own like garbage collector if we want to use it. I mean, I want eventually to not have the garbage collector, but we will still want a garbage collector as a library, I think. Anyway. But then compilation times, yeah. Member field, member info, initialize, offset. What we're doing, so we have like the list, which is just a member field, and then we want to basically initialize type info for a struct, right? Like basically I have specified the minimum information, and then the remaining information is going to be like platform dependent on the result like this, and then we return the result here. You'd highly recommend implementing coroutines mostly at the language level. Yeah, well, I was just doing the continuation passing style transformation. And that would be the job of the minicast, I think. Here. So yeah. You've done it at the assembly level for Odin. Wait, did you work on Odin? Or did you work in Odin? Are you the developer of Odin? No, the developer of Odin is called, I remember his name, Ginger Bill, right? You're not Ginger Bill. Unless you helped him. You did it as a library, I see. The coroutines as a library? I see. Initialize type info for struct. So this is in C then, right? So here's what we have. Initialize type info for struct is a thing which is like type info, right? This doesn't return anything. If you wasn't into the Odin compiler, you would not have done it in the same way. Okay. Right. So this is where we calculate offsets and the things, right? So yeah. And since this is like the run type information, we need to like basically mimic the C behavior of how C calculates the offsets and like padding and things like that. Right. But for the JavaScript, we just need to know if it's an object. So we basically say that initialize or type info for struct is type info, and since we like this is in the name, right? This is specifically for struct, so this will just say that type info allocate info is object is true. You could just generate C struct definitions and dynamically cast to them. You cannot generate the C struct definition at runtime of C. You cannot, no. Like I would get it for the statically known types. I would just use the type information for statically known types by, like this is basically the job of this type info, which is going to be implemented and like, yeah, we cannot enumerate all the possible types at compile time. Yes, we cannot. That's the whole point, right? Once again, existentialization. You have like, if you have a generic type like over here, right? Then we don't want to like, because we don't want to monomorphize, we don't know all of the possible types that we're constructing here, right? So we want to construct the generic types at runtime, and understand the layout by having the type information about the T. We want to know the type information about the struct itself, right? So yes, we cannot. I mean, like I said, there is going to be like multiple modes of the compilation. One of them is the existentialized, when we do this at runtime, and another one is the monomorphized, where we can enumerate all of the possible types at compile time, right? And yeah, and the reason is because we want to have this either fast compilation or fast runtime, right? And the existentialization is supposed to work fast enough. So monomorphization, I want to delay it as soon as for as long as possible. You could still generate a dummy object definition and put the offset of its fields into the type info struct. But you cannot do that because, like, how do you generate this dummy object here, right? Because, like, the field here is of type T, and the size of this type, alignment of this type, determines the alignment and the size of the whole type, right? So if this is known only at runtime, then the whole thing also can only be known at runtime. Like, what is the dummy object that I would generate here? Well, I mean, I guess we could have like basically for all of the variants of how many fields, and like for every field, like because certain we can treat basically the certain types which are having the same alignment and the same size, I guess, as the same type when we are calculating the things, right? At the point you create an instance of it, it has a specific type. At the point you create an instance of it, you have a specific type. No, but we don't have a no. Yes. So like over here we're having this code, which is a generic function which returns this thing, right? It returns the this type. So I don't have it available to me yet, right? Because I need to actually allocate this thing, and in order to allocate this thing, even on the stack, we need to have the runtime information available to us already, right? So I don't have this. Right over here, this is the C code, right? Well, I mean, over here in this C, specifically in this C implementation, I did allocate like this concrete type, right? So this is the generic type instantiated with an int. Over here, I actually do have it. Actually, hold on. Yeah, I do have it here, right? Because in order to return it, we want to allocate it on the stack, so we want to allocate it in the caller. And the caller knows the concrete type. Indeed. And since the caller knows the concrete type, we could pass the type information of the generic type T here, right? Well, I mean, yeah, this is the result, right? So we can have this. But what if I wanted to have like a temporary object of the generic type, you know? So like in this case, yes, I am returning this to the caller. So I have the concrete type in the caller. But if I was in this function using a temporary thing, then I would allocate it on the stack over here, and I would want to allocate the generic type here. And in this case, I would not have it, right? Because I need to allocate it dynamically instead. The problem is that you can create new generic types from other generic types at runtime. Yes. Well, I mean, think about I don't know, what's the code? Let me come up with a good example. So you have the like this is a function that just like initializes this thing, right? But what if we do doing the alignment calculation manually would be pretty easy. Yeah, I think it should be pretty easy. I'm just saying that we have to do it. But in this case specifically, yes, we don't have to. Like, you see how this generic function is actually calculating the type information of the generic type of T, right? At runtime here. But actually in this case, when we are returning the result, I can maybe it probably is okay to pass the type information of the result from the caller here too, similarly to how we pass the result, right? So maybe this would be better in terms of performance if I don't calculate the generic type T here, right? But we instead say that we have type generic type of T, right? Because this thing can be calculated statically because we know the fully monomorphized type here, right? Well, I mean, the other option would be to not generate the monomorphized types like at all, even when we have it, but I think this is good. So that like we only like do this stuff, dynamic stuff for the generic code, but not for the like non-generic code. I think. I don't know. Probably makes sense. You could also make all structs back and do manual padding. Yeah. So over here we want to like have the type information, right? So we want generic type of int32 type. Yeah. But yeah, that's just an optimization. Let's not do that yet. Well, maybe this over here is also the optimization, technically, right? We could make the falloc for every variable. I don't know. Okay, so this is working, right? This is also not necessarily on the heap. It's like in the global arena allocator for the type informations. So they should not like literally call the alloc here, the malloc. But okay. All right, it's been 5 hours of me doing nothing. Well, we're designing things, I guess, today. A little bit. Okay. So we have generic type, then we have the generic function. And instead of doing this like directly, I am actually doing the closures right now. And I think we will do that. So we have a like instead of flattening this into a single function, we do a function that takes t, and then we return a function that takes the remaining two parameters, right? And also like in the minicast, I think instead of like saying void star result, we actually like return the any type, but because we cannot return the any type in C, we automatically would convert it into the void star result, I think. Yeah. Wait, no, but I cannot do that, right? Wait, what did I do in JavaScript? Yeah, we still like do the results here. So I actually want to do that always, even in minicast. Yeah, I think it's the job of the cast to minicast that is going to do this transformation. Generic function is, so this takes t, which is the type info, and this returns the function that takes this field, right? Which is, so in this case it is any, because we take ownership of that, right? And returns, no, it's like any, and like the result is a reference to any. We'll do this, right? So we have the function which has like the field which is of type any, and result which is a reference to any, and like this. So we want to say that generic type of t is equal to generic type of t, like this, which, yeah, let's do that. And then we want to get field. We call it get member here of So result field is get member of the result, the member, which is the field number 0 here, right? So yeah, we get member of the result, generic type of T, members number 0. And then we need to copy the type from one place to the other. Wait, I'm actually wondering why in this initialize, right? Why did they say the copy? Why did they say copy is a required thing? Like, why do you not just do the mem copy? What is this required for? Isn't it supposed to be the trivial copy always? Or is it because in Swift you can actually like copy like the vex and stuff? Do they have C++ like copy semantics in Swift? I thought they had something similar to the like ownership semantics in Rust, where yeah, I guess this makes sense. This is basically like the clone trait in Rust, right? I just thought it would not be in the case there. So you cannot leave the object in uninitialized state. Oh, you probably can. Like if a struct is an owned pointer, you can just copy it bytewise. Well, yeah, that's like move versus actually like cloning the thing. Yeah, maybe Swift does not have the yeah, copy is recursively done. Yeah, I suppose. So Swift ownership semantics. Like they have the one introduced in 5.9, provide explicit control over memory management and value lifetimes. And to eliminate necessary copies and reference counting, right? So yeah, like because they did not have it before, they were actually copying the stuff. And this paper is probably like of their original implementation. Where's the date here? I mean, this is from 2025. So I don't know. But they have borrowing and consuming like keywords these days, right? So we have this result field. Yeah. So I just need to basically copy. I still need to copy basically, right? But in C, this is going to be the mem copy, right? And in JavaScript, we need to also introduce the copy semantics, which, by the way, right now my Kast, I have had a couple bugs because I have not implemented the copy semantics, and we just like, yeah, because in JavaScript the copy would need to be recursively called too, right? So we copy the we copy result field from the field. So this is any, right? In this case, I want like maybe we cannot have owned any in minicast. And we'll have reference here, right? So we'll copy this using the T using T, right? Yeah, so we have in our runtimes the copy, which is the target, which is any, the source, which is any, and the type, which is type info, right? And in C we just say native mem copy, target, source, and over here the size, which is t dot allocate info dot size. Oh wait, hold on. By the way, I know that. So this size is actually useful then, right? Which is, if you make the size different from stride, where you don't care about the final padding, then copying the data is faster, right? Even if you allocate it still using the stride always, copying can be faster because you only care about the bytes that are not padding bytes, right? Not by much. Well, I mean, yeah, because like the final padding is like at most 8 bytes, and like it's whatever. But I don't know. Isn't like the mind of C people supposed to think about all of these micro optimizations all the time? And most small strides don't have any overalignment. Yeah, but like there is still the overhead, right? Yes, of course it's not by much, but there's a lot of things that are not by much, and then when you combine all of those, that can like be combined into much, I guess, right? And in JavaScript, the copy, and in JavaScript, the copy is the recursive, yes. Which I have already had it in my old runtime, by the way, over here somewhere. Right, we do the oh no, I do the deep equal, right? But I never had the deep clone. Right, but now we have the type information, and we can actually write that code directly in minikast, I suppose. Right? Like yeah. We basically need to copy it field by field if it's an object, but if it's not, then yeah, we have this is object, right? So we say that if t allocate info is object, then we do one thing, and otherwise we so in the other case we just literally say that target is equal to source. Why does the camera feel even more cinematic today? I don't know. I think it's the same as yesterday. Maybe I moved it a little bit. I don't know. Hello, Rensky. So if this is an object, then I actually need to say first that target. Yeah, we basically need to like allocate it. Not separating length from stride was probably a mistake. My hands look messy from down here. Why doesn't Rust have an and then for error variant? It's called map error. Well, I mean, it's not map error, right? Well, I mean, you have the map error. You can implement and then using maps, technically, right? Well, no, map, yeah. And then it's like if you do and then for the error variant, it's like implies that you can return okay after having the error, right? Which is like a rescue. It's like the catching, potentially. It would be called something else. Hold on. Let me take a look at the standard library. Exactly what you need it for. You can do this. Is end. That's what you want, right? Oh no, this is like no, this returns in Boolean. You want like you want something similar to this, but it should not return a Boolean, but it should be more generic over the result type, basically. Right? Well, is it? Wait, hold on. Isn't this just unwrap or else? No. It is or else. That's what you want, right? Or is it this one? That's what you want, or else. There we go. It's called or else. Right. So here we just say, so this is the primitive type, which we just like assign like this. And if it's not a primitive, then I'm going to create the new object. Right? And then copy all the fields, right? So we say target is, so we say target is, we create a new object basically here first. And then I say I need to iterate over the fields. Similarly like this, right? Should I call this not like type info, but actually just T? I think that makes sense. Let's call it T here. So when we copy this, we go over the T, and it's not fields, by the way. It's members. And it's like member. Setup member. Can we rename all of the fields to members? Member offset or name. So we go over the members, and then we like copy member. We copy member, and this undefined. Yeah, this is because it's the context, right? So then we say that copy member is member info. So this should be like get member of the target member, right? We need to like copy. We need to copy get member of the target member, get member of the source member, and using the member type. Like this. There we go. Bum, 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 bum. So we have this generic function, which just like copies into the result field. The result is already allocated and stuff. So all that's remaining is to write the main function, it seems, right? And we just say we call the generic function using the T. So T in this case is supposed to be int32 type info, right? We have reference to this. Right. And we want generic function type info. Right, so then we have like the actual argument. So this is the generic argument, and this is the actual argument, which is the so we want the reference to const 1, 2, 3. We'll have the const 1, 2, 3 integer, which is 1, 2, 3. Right, and then the reference to x, where x has the type, generic type of int 32, which, so like we can like monomorphize the type here, or we could instead say, if this is the generic type, then we could just say generic type int 32, and we say like allocate type on the stack, this one, right? So that's what we do. And then we just have a reference to this type. We allocate on the stack. This already gives us a reference. So like I just say x here. The only issue is then like this is like not like this is dynamically typed now, kind of. It's a little bit annoying. So we don't want to do this. We probably actually want to specify the type, which is like generic type of int 32. And this is where we do the monomorphized type. So it's going to be a struct with field being of type int 32, right? So we instead say that this of type generic type of int 32 is equal to uninitialized. Oh, by the way, so like it means that the uninitialized should actually like initialize this stuff when I transpile it, right? So because right now in JavaScript I say just undefined here, but in case of the inner structures it will not work because I actually need to like do this initialization, right? Of the fields, right? If it's an object, then I need to like initialize all the fields. Why replying say clip daily? What? Replaying the same clip daily? What do you mean? What clip? Or do you mean like the trailer of my game? Because I only have one trailer. I'll do a different trailer, but then like it would be 2 clips, I guess. It's because I don't have a different game, unfortunately, yet. And this one is not finished either. Yeah, that's trailer video. You should I should wishlist my game on Steam. And there is a demo there that you can play. Okay, so what is going to happen right now? Let's do this. Cast mini compile tests mini generics, right? Okay, so right now this is not working, right? Okay, list like this. Type info is not found. Type info is not found. Right, because type info is specified in the like I need to actually compile the two files now. Tests mini is it called target runtime JS, right? Okay, now over here, this that needs to specify the result type. Member offset or name is not found because this is for some reason lowercase. Okay, expected expression got type info, right? So I need the type info to be the primitive, right? Yeah, I'm pretty sure that I want the type info to be the primitive here in the minicast. It's okay. And I think the runtimes they go into like the source. This is not part of the tests, right? So we say like source mini backends JavaScript C like I think we do it like this. We have JavaScript, and this is called the backend MKS, or no, not backend, right? Runtime MKS, and this is going to be like runtime MKS for C, which we don't do yet, but right. So there's going to be so this runtime is in source mini backend JavaScript runtime, right? There we go. So I do the type info primitive. All right. And like the problem with the JavaScript though is that now that I was trying to like make it work with C, this is going to introduce a bunch of problems in the JavaScript actually, right? Can JavaScript like optimize the thing? So I'm passing references as like closures as setters and as getters, where I could instead just return the thing here, right? Oh wait. I think we can like I think what we can do is well the any type is going to be the reference anyway, because this can be a primitive, yeah. But I guess I could optimize the compilation of a reference to the type that I know is already the struct type, the object type, right? And then we would not need the functions there. Yeah. But if I have a reference to any though, like this over here, how do I optimize this? How do I optimize this? If I want to, I don't want to do too much work optimizing JavaScript, but wait, hold on. Actually, this is not a this is not always correct. I need to have different type pointer types then, right? Because if I have a reference to the object, and then like I might want to reassign it to a new object, but I'm still holding the reference to this original object somewhere else. Yeah, I cannot even do that properly. Okay, maybe we just embrace the very slow compilation and like we instead, yeah, we just don't care about this maybe. And I just work on another backend. We don't care about JavaScript, right? At all. We just need it to work. Yeah. I need to restart the Kast language server so it's like actually working. Oh wait, I think it's working. Oh, the C runtime. It started working. Oh, but this is still not parsed for some reason. Wait, what? But why? I don't get it. Let's maybe let's try like exit the VS Code completely or something. Why is it called boost? Oh, okay. Wait, what? I don't want to do this. Name Kast. Maybe I do that. Okay, let's close this. Let's close all of that. Reopen the self-host. No, it's still not here. Like I don't get it. There is something wrong because like it definitely works, but then it doesn't. Is it a bug in the language server actually? Because the language server for some reason is trying this instead of like the other thing. Hold on, LSP state, right? We have syntax of the minicast. Get syntax, minicast syntax file. Get syntax. Yeah, it's like I'm using. No, I'm not. I'm not even using that. No. Something is wrong here. Anyway, next time I will try to like to implement so that the minicast can compile this example with the generic stuff. I'll figure out this bug, right? So I need to implement a couple of things like the type info primitive and maybe some other things. We'll see. Like the list, I guess, the list expression, which we'll probably like get rid of eventually and replace with something more lower level. Maybe we'll see. But yeah, let's call it here for today. Good progress, right? Boom, boom,
the bushwhackers 20 years later, you heard? Y'all don't ever disrespect me looking like the welfare Marlboro man, you heard? Y'all don't ever disrespect me looking like a Puerto Rican Karl Lagerfeld, you heard? Y'all don't ever disrespect me looking like Seth Rogen's little brother.
Any new language developers on Twitch? C and shell scripting like it's 1979. I think they talk in chat instead of talking with microphone, unfortunately. All right, let's go to
This here
P2.
translates to
Diego?
cache.
Question mark?
Does
I'm just
is
ending the
in
stream
bare
here.
form. This translates
Just
to
looking
mark
for who to
those
raid.
dependencies in the cache, and
Let's go here.
also making sure they are there.
Thank you guys for watching. See you
if
next time.
The optional dependencies, like
Bye.
if you build on your Itanium with half of the packages not installed, you would not get the steps. So what this ensures is that they are
Bye.
saved in the cache, and if they already were there, they are marked optional.